Hello info person, this is Anton, and today we're going to once again talk about Uranus. And yeah, pretend I made some kind of a funny Uranus joke right here. Anyway, so we do actually have some really exciting discoveries coming from Uranus, some actually solving several mysteries, and some somewhat surprising. And because this is one of those objects we've only visited once during the Voyager 2 mission, discovering anything new from this bizarre planet is always super exciting. But I guess first, let's start with some of the new observations and some of the new images, in this case actually captured by two separate telescopes. From the Hubble telescope, right next to the observations from the New Horizons probe. Here's basically what it looks like side by side. But there is actually a really important reason why this was done. This was actually a kind of an experiment in order to test our observations when it comes to exoplanets. And so here in late 2024, researchers used Hubble and New Horizons to take a picture from two different perspectives. Here's roughly how these perspectives compare. But the point here was to study direct imaging of various exoplanets, specifically when it comes to things like, for example, habitability. And to study this, they wanted to capture a planet from two different perspectives and from two different distances. But before this was done, they did have an expectation. They basically expected Uranus to appear slightly differently in different visual filters, but potentially still look somewhat similar. And instead, they actually discovered that Uranus was a lot dimmer in the New Horizons data compared to predicted values. And because New Horizons here was much farther away, approximately 61 AU away from planet Earth, here the observations were kind of mimicking what we usually get with various planets around other star systems. And so because it appeared dimmer, it meant that the angle of observation actually mattered. So here, because this was observing the planet during its partial phase, when only a portion of the planet is illuminated by the sun, the resulting brightness was much dimmer. And additionally, they also discovered that during this partial phase, the atmosphere of Uranus was actually reflecting light differently too, as in Uranus appeared different in color and was showing very different molecules compared to what was visible to Hubble. And that by itself was a really important discovery because when observing other exoplanets, we might actually overestimate certain things or might see things that were previously underestimated. And so this particular test was really important for future observations of planets where we might one day discover some kind of habitable conditions. But naturally, this is the first such observation, so basically this is just the start. Additionally, we had another study and a separate observation that basically solved one of the older mysteries when it comes to Uranus. And here this was the observations between 1992 and 2018, mostly in the infrared light, that established that for some reason the upper atmosphere of Uranus, or the so-called thermosphere, for some reason was cooling down and went from approximately 700 Kelvin down to about 450 Kelvin in just 3 decades. And it was not clear what's happening here or why. Now generally, for a lot of different planets, including Jupiter and Saturn, there is a region above the atmosphere that's usually super hot. Earth actually has this too, and it's usually somewhere between exosphere and mesosphere, and normally starts at an altitude of 80 kilometers. And even for Earth, temperatures can be really high, between 2000 and 2500 Celsius, or 3600 to 4500 Fahrenheit. Here's roughly what this layer looks like when seen from outer space. But for some reason, for Uranus, this layer has been continuously cooling down ever since the first observations in the 1990s. And for Uranus, this layer is much higher. It goes as far as 50,000 kilometers above the surface. And so during the Voyager 2 flyby, this was in 1986, he was able to measure the temperature here, and this was our first value and the first measurement. And ever since then, scientists have been continuously measuring thermosphere by mostly using infrared telescopes. Naturally, they've been doing the same for other planets as well. And of all the planets, it's really only Uranus that seems to experience these unusual cooling changes. And here at first, scientists were not sure how to explain this. It didn't appear to be the effect of seasonal changes, and it wasn't connected to the solar 11-year cycle. But the new study by Masters and his team potentially solves this problem. As you can see from the title, the answer seems to be solar wind. And looks like here, the solar wind, which also declined in power in the last 30 years, seems to have influenced the magnetic field around Uranus, because apparently it has a lot of control over Uranus' atmosphere compared to planets like Earth. And so because of the declining solar wind, which is basically a bunch of plasma particles, the magnetosphere of the planet very likely expanded, which then basically led to the expansion of the thermosphere, which led to the overall cooling. And so here this seems to be the effect from the overall decline of the solar wind hitting the Neptunian atmosphere. And though by itself this might not sound too important, it actually is. Mostly because this actually suggests that for these really far away planets, the solar wind seems to have much more effect when it comes to the control and the heating of the upper atmosphere. Here you can actually see there's a graph showing a direct correlation between the pressure from the solar wind, the Uranus magnetosphere, and the temperature in the Uranus thermosphere. And so here, because the number of photons reaching Uranus is actually relatively minuscule because the sun is really far away, it's really the solar wind that seems to play a much bigger role. And this is extremely different from what we've seen around other planets in the solar system. And so for planets like Earth and even for planets like Jupiter, the photons, or I guess sunlight, controls the temperature directly. And that of course includes the temperature of thermosphere. But for much farther planets, it really seems to be the solar wind, or the plasma coming from the eruptions from the sun, that does actually change quite dramatically depending on the solar weather. And this of course implies that we can expect something very similar for a lot of different exoplanets that orbit at faraway distances. If these planets have a large magnetosphere, and if they orbit far enough from the star, most of the control of the temperature is going to be done by the stellar wind and not by the heat emitted from the star. So stellar radiation, or sun radiation in this case, is basically not very significant. But when it comes to Uranus and its magnetosphere, there is actually another mystery. And this is once again from the Voyager 2 that visited Uranus approximately 50 years ago. During its flyby, it actually discovered that for some reason, the magnetosphere of Uranus was super different from what astronomers expected. Not only was it very strange in shape and seemed to be somewhat lopsided, it was also extremely strong. It contained a super powerful radiation belt whose intensity was very similar to Jupiter, and this was kind of hard to explain and was completely unexpected. I mean, this was a much smaller planet, way smaller than Saturn, and Saturn did not have anything similar. Not to mention that the pole in this case was also shifted dramatically compared to the spin of the planet. And more importantly, there was no actual way to explain any of this, and no known source for any of these energetic particles that could produce such an intense belt around Uranus. These belts are basically made out of plasma or ionized gas, and it wasn't clear where this plasma was coming from. On top of this, Voyager 2 also revealed that none of the moons were producing any interaction with this magnetic field, essentially suggesting that all of the moons here were entirely inactive, not producing any emissions and without any geological activity. And that was a bit strange because when looking at moons like Miranda, its surface actually does suggest a lot of geological activity. So maybe it was just not active anymore. But we might finally have an answer to all of this, and it seems to be just an anomaly. Turns out that at the time of the flyby, something actually happened to the Sun. Something that only happens approximately 4% of the time. Here we had an enormous emission of that solar wind. So basically Voyager 2 potentially saw Uranus during an extremely rare cosmic occurrence. Because the solar wind hit Uranus at just the right time, it actually compressed its magnetosphere, pushing plasma out of it and creating these powerful belts. And so these very powerful radiation belts were possibly only powerful during this time. And had Voyager 2 arrived at a different time, like for example right now, it would very likely see a completely different picture. In this case, a much bigger magnetic bubble and very weak radiation belts. All of this was described in a study by Jamie Jasinski and his team in a study that was just published in Nature. So basically here the answer was an extremely high pressure from the solar wind once again that very likely just skewed our observations. Which kind of suggests that the magnetosphere of Uranus is potentially not that different from other planets after all, or would definitely appear very differently if we try to visit this planet once again. While also confirming that this is still one of the most misunderstood planets in the solar system, and more importantly, a planet that potentially contains super exciting moons. And that's of course the other two discoveries. Unlike previous assumptions that the moons were basically geologically inactive, this study suggests that some of them could be active and possibly do interact with Uranus at all times. And here we have two studies about two separate moons. The first one is the famous Miranda. Turns out all of these very bizarre and hard to explain features on the surface potentially hint at ocean hiding underneath. And so here the study by Khaled Strom and his team tried to explain all of these very strange, very bizarre shapes as if something scratched the surface of Miranda by conducting computer simulations and by trying to match these simulations with what could be happening inside. And well, the conclusion is that these seem to be the result of tidal forces from the neighboring moons pulling on Miranda for billions of years, but these features could only form if there was a very specific type of structure inside. And that structure has to be something like this. The best match here is if Miranda has a huge ocean, possibly 60 miles or 100 kilometers deep, but beneath 30 kilometers or 19 miles of brittle ice. And because this moon is only like 230 kilometers in radius, it means that this ocean would be almost half of the entire moon, which is really surprising. But I guess not surprising if you consider how strange this moon looks. And so all of these shapes were possibly the result of resculpturing of the moon, because it is basically kind of malleable. All of this liquid inside makes it very easy for it to change appearance, especially if there are tidal forces close to it. And so all of this is just a result of external stress. It would have to have some kind of an ocean at least 100 million years ago, and possibly even today. And the only way the ocean would be still liquid is once again through tidal interactions between Miranda and its partners. And so in essence, this is probably one of the best explanations we have for what's happening here and for why Miranda is just so bizarre. But then there's another moon called Ariel. And Ariel is also now super exciting. A separate study tried to understand the surface of Ariel as well, and especially those unusual white patches. Here we know that Ariel, for some reason, is actually covered with a lot of carbon dioxide, and here we're talking about carbon dioxide ice, especially on its trailing hemisphere. And though finding ice so far away from the sun might not be an issue, it is an issue when it's carbon dioxide. Carbon dioxide should actually turn into gas unless the temperatures are even colder. And the study by Richard Cartwright and the team that used James Webb to try to figure this out potentially found a solution. Here, to their surprise, on top of carbon dioxide, they also discovered carbon monoxide. And carbon dioxide deposits were also extremely rich. This is actually some of the richest carbon dioxide ice deposits in the entire solar system. In some locations, the thickness of this ice can be as much as 1 centimeter, or even more in thickness. But carbon monoxide made no sense whatsoever. This gas usually disappears unless the temperature is down to about 30 Kelvin. But the temperature on the surface of Ariel is expected to be 60 Kelvin, so at least 30 degrees warmer. And that of course meant that something on the surface was continuously replenishing all of this ice before it becomes a gas. And the only way this could be achieved is through maybe some kind of a cryovolcanic activity, or essentially through geological activity, confirming that Ariel is also geologically active. And so here all of this ice very likely escapes through various cracks, eventually depositing on the surface, which also confirms that Ariel seems to contain a lot of these substances underneath. And on top of this, it also contains a lot of carbonate minerals, or a lot of different salts that can only be made through interaction with liquids, which also suggests some kind of an ocean, just like Miranda. And so basically both of these moons potentially contain a subsurface liquid ocean that could still be liquid even today, and thus could have a very high chance to be basically habitable, or at least have conditions for potential habitability and somewhat unusual life-sustaining environments, very similar to what existed on early Earth. Naturally, this is very similar to what we observe around Europa, Enceladus, and other ice moons, but finding this on Miranda and Ariel is a little bit unexpected. And the only way these oceans are possible is once again if these moons are tidally interacting with each other, which creates a lot of heat inside. And so this basically suggests that any kind of a gas giant that contains large moons orbiting close to each other has a very high chance to have moons with large oceans and possibly life-sustaining conditions. But obviously we're not going to know more about these oceans or these moons until a mission to Europa in the next few years. We're going to be talking about this mission when it actually starts, but at least for now, these are still really exciting observations and really exciting discoveries. Hello InfoPerson, this is Anton, and today we're going to discuss some of the recent discoveries about what's known as the officially largest star in the universe, or basically the largest star we've discovered so far, whose measurements have been extremely accurate. And specifically, we're going to be discussing a star that you're about to see right here, referred to as WOH G64, and some of the recent discoveries that were kind of a little bit surprising. But before we talk more about the star, let's actually discuss this idea of largest stars, because this topic has been covered by a lot of different channels on YouTube, and you'll actually always get a completely different answer. As a matter of fact, when I just started making videos on YouTube, a lot of discussion was about this star, VY Canis Majoris. Back then this was considered to be the largest we've ever discovered. But not so long afterwards, it was beat by this star, known as UY Scuti. And then within just a few years, it was once again a different star, this time known as Stevenson 2-18. But if we actually look at the list of some of the largest stars, only some of these stars, such as VY Canis Majoris, is even still in the list. A lot of the other stars have actually moved somewhere down the ranks, or are actually not even on the list anymore. And that's really for one simple reason. In many cases, when it comes to these really large stars, first of all, defining their borders is actually kind of challenging, so we don't actually know where to even measure from. But second of all, a lot of these measurements are usually based on two major things: the exact distance to the star and its luminosity. And so in many cases, the distance was measured incorrectly, with a lot of the new measurements coming from the Gaia telescope, basically reworking these numbers and helping us realize that many stars, including the star UY Scuti, are actually not as large as we thought. And so you can actually find one of the older videos on the channel from just a few years ago, where basically the largest star, UY Scuti, was no longer even on the list. It was much smaller than initially assumed. But despite of this, if you were to look at the top of the list, there's one star that's always been there. And that's actually a star that's basically almost at the theoretical limit of how big a typical star can actually get. Here we're of course talking about a limit of a red giant star, a star that one day is going to contract and then go supernova. And well, that star has always been WOH G64, a star that's part of the Large Magellanic Cloud, the neighboring dwarf galaxy next to the Milky Way. And based on a lot of previous measurements involving different telescopes and different techniques, the distance to the star has always been established to be approximately 160,000 light years. And so because the distance in this case was measured much more accurately, and because its luminosity was also measured pretty accurately, for decades now, this star has been basically referred to as the Behemoth star. And that's actually ever since its first discovery in the 1970s. And because it was discovered by Dr. Westerlund, Olander, and Hayden, the first letters of their names essentially formed WOH, or the name for this star, and many other discoveries by this trio of scientists. There's actually an entire catalog of WOH objects, all of them discovered in the 70s. But here, this object stood out quite a lot. Even back then, it appeared to be extremely large, with its size measured to be anywhere between 1500 radii of the Sun, all the way up to about 2000. And that would basically make it as large as stars can theoretically get, making this one of the most, if not the most luminous, and most massive red supergiants ever found. But because its radius could be measured so accurately, for many years it was always somewhere on top of the list of the largest stars. But strangely enough, in the last 3 or 4 years, it essentially became number one, and nothing seems to come even close to being larger. And that's despite the fact that its luminosity and its size have been kind of downgraded. Currently, some of the most accurate calculations suggest that it's about 1540 radii of the Sun in size and approximately 282,000 luminosities of the Sun, which basically means that if you were to put it in a solar system, it would swallow Jupiter and all of the other planets closer to the Sun. And that's on top of some of the other discoveries from the last decade that were not very easy to explain. For example, back in 2007, researchers used the Very Large Telescope to observe the star once again and discovered that it seems to be surrounded by a very large torus-shaped cloud, a massive cloud of dust that seemed to be orbiting around this really large giant star. It wasn't really clear why and what this dust is doing there, but it was there. On top of this, this is a variable star, and it seems to change brightness every 800 days. Now that's not very uncommon, even Betelgeuse does this, but here sometimes the brightness changes are a little bit extreme. Moreover, the mass loss here is extreme as well. It's the highest known mass loss of all red supergiants, equivalent to about 1 Jupiter every single year. So basically this unusual star evaporates so much mass that every year it loses an entire mass of Jupiter through the process of very powerful solar winds. And that's because we think that this was an extreme star even from birth. It was probably about 40 solar masses in mass, and when it just started to expand, it was probably even much larger, possibly up to about 3000 radii of the Sun, emitting more luminosity and losing even more mass. And this was discovered by looking around the star and discovering a huge amount of dust around it that was expelled in the last million years. But despite of this, it's still extremely similar in terms of properties to pretty much every other supergiant star we've discovered, including Betelgeuse. So here the physical parameters are exactly the same as for VY Canis Majoris, UY Scuti, Betelgeuse, and many other red supergiants. But some things are a little bit different. For example, this is also a source of many different maser emissions. These are basically kind of like lasers, but emitted in microwaves. Here there are many different emissions by hydrogen, oxygen, and even silicon oxides, which though happens in other stars, in this star seems to be once again a little bit too extreme. And so because of these extreme observations and certain observations that were difficult to explain, there's actually always been a theory that maybe this star has some kind of a partner, possibly an O-type star, but just much less luminous, which disturbs the supergiant once in a while, producing some of these extreme emissions. But because it was basically hidden by the dust clouds, and basically hiding somewhere within this torus, confirming its existence was always kind of challenging. Intriguingly, as a side note, you might want to check out a recent video about Betelgeuse, where a similar explanation has actually been given for some of the unusual observations from Betelgeuse, including its dimming. So both stars potentially contain partners. The video about this should be in the description. But now, years and years later, we finally have the most accurate observations, once again by the Very Large Telescope that's now been updated and possesses much more resolution and more power, revealing an extremely unusual gas that seems to be poofing away from the star, but in a very bizarre way. It basically forms a kind of a egg shape, the shape that you see right here. And well, once again, this is somewhat challenging to explain, because this gas should be more or less spherical and symmetrical, yet this unusual cocoon seems to be stretched by something possibly influencing the star. And the question here is, so what's happening? But even before we discuss some of the potential answers, here I have to highlight the obvious. This is actually the first time ever researchers have been able to take an actual physical image of a star in a completely different galaxy, 160,000 light years away from us. Basically the first ever zoomed in image of a red giant star before it goes supernova in a completely separate galaxy. Obviously we have pictures of Betelgeuse and some other red supergiants, but this one here is much farther away. But in this case, there were also some surprises as well, with the biggest one being luminosity. Turns out the star has become dimmer in just the last 10 years. And the only explanation researchers have is basically once again right here. It's quite possible that it just shed a lot of mass from the center, and all of this shed material resulted in a dimming in a very similar way to what happened to Betelgeuse back in 2019. But in many red supergiants, sudden dimming can also be a sign of potential inevitable supernova sometimes in the future, near future. And so here this is a pretty exciting discovery. Now nobody expects us to go supernova yet, not for another 100 years or so, but this bizarre shape and the unusual stretching is definitely kind of surprising. Mostly because based on modeling and based on many different predictions, scientists looking at the star expected to see something entirely different. Much brighter, much more spherical, much more symmetrical. And so for all we know, maybe WOH G64 could be actually in its final life stages and is basically getting ready to throw off even more gas before it prepares for a major supernova. Or maybe, and this is actually a much more likely explanation, here we have the exactly same explanation as with Betelgeuse. Both the cocoon shape, the bizarre shedding, and even additional features, like the dusty torus you see right here, could all be explained if it had some kind of a massive partner that we're just not seeing. By having an undiscovered companion, it could be just experiencing a lot of disturbance as a much smaller star interacts with its envelope and causes occasional eruptions while mixing and stirring the gas in a certain way. Or at least that's the overall conclusion from the study by Onaka and his team that you can find in the description. And so in essence, that's basically what we have right now. We have the observations from the officially largest star we've discovered so far, and the star itself seems to be producing some surprising emissions and is also dimming just like Betelgeuse. Okay, it's about time we've talked about the Milky Way galaxy, and specifically some of the more recent discoveries from the last few months that once again kind of surprised everyone. And that's because in the last few years, the Gaia telescope, combined with observations from other telescopes, has been consistently rewriting all of the fundamental knowledge we have about our own galaxy. But on top of this, in the last few years, there's also been some advances in observing a lot of other frequencies, including various frequencies that actually allow us to study magnetic fields. And so in 2024 alone, there's actually been several papers discovering new things about the magnetic fields, revealing the Milky Way galaxy in different ways we've never seen it before. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries about the Milky Way galaxy and discuss some of this recent research with all of the studies, as always, available in the description below. And I guess here, let's begin with those discoveries in regards to various types of magnetic fields in our own galaxy. And that's because by studying polarization, we can generally start mapping the magnetic field even of various extremely distant objects. For example, we know that a lot of different gas in a galaxy is not really spherical. Most of it usually has some kind of an axis, with various particles aligning with the magnetic field, which can then be observed from planet Earth. And so as a result, we can actually study various gas clouds, or actually even stars, and various galactic structures, and then see if there's any magnetic field in them. And so as all of these grains align with the magnetic field, and as they emit polarized glow, we can start making these polarization maps, which can then allow us to measure magnetic fields in the entire galaxy. And well, looks like this year, the scientists have actually started to come up with new strategies and new techniques that started to produce huge magnetic maps of the entire night skies. For example, in one of the studies from just a few months ago, researchers used a new technique that helped them measure polarization of 1500 various stars, which when combined with observations from the Gaia telescope, allowed them to map magnetic fields with extreme precision. And although this is just a pioneering technique showing us what we can actually do in the future, this is a really important first step in helping scientists demonstrate that various types of starlight polarization, combined with the data from Gaia telescope that shows us the distance, can reveal an incredible complexity when it comes to magnetic properties of various types of gas in a galaxy. And so depending on polarization, different frequencies of light will actually move through ionized gas at slightly different speeds, which allows researchers to map all of this extremely precisely. And well, one of the first discoveries from a separate paper, also in the description below, was trying to establish if the magnetic fields in the Milky Way were more or less uniform or a little bit more chaotic. And that's because based on previous assumptions, a lot of research showed that it should be more or less uniform, with the field possibly following the disk shape of the galaxy and mostly changing as the disk changes as well. But once again, by using Gaia telescope and by looking at distribution of stars and various nebula, here the researchers looked at the three-dimensional map of the magnetic field, discovering that it was not uniform at all. Here, nothing seemed to follow any kind of a galactic plane, and various magnetic fields were actually forming extremely complex shapes. But much more importantly, they also discovered that many of these fields and many of these magnetic lines were also interacting with stellar nurseries, very likely affecting the motion of gas and the motion of dust, and thus affecting star formation, which actually explains how certain nurseries seem to form. In some cases, it's actually difficult to explain if it was just gravity at work, with a much more likely explanation being very hectic and very unpredictable magnetic fields. But things get even more interesting in a separate study, because here researchers focused on something even more extreme and even more mysterious. We're talking about the structure known as Rosetta bubbles. And essentially it's an unusual structure that looks like bubbles coming from the center of the galaxy, but bubbles extending thousands of light years away from the galaxy, but only visible to X-ray telescopes. And so a while back, it was actually proposed that there might be two possible explanations. Either this was some kind of a major emission from the central black hole, kind of like what we usually see in a lot of other galaxies, or maybe this was actually a result of extremely vigorous star formation millions of years ago. But it was very difficult to prove which of the answers made more sense. But this is exactly what's been done in this recent study. By once again studying polarization, and by identifying several magnetized structures inside these bubbles, researchers were able to reveal something we've never seen before. Here they discovered several magnetized structures reaching heights of over 16,000 light years that seem to be extremely organized and even formed an unusual thin filament that seemed to be 3.5 million Kelvin in temperature. But these filaments were coming from a very specific region. They were not coming from the black hole, but instead seemed to be coming from the end of the galactic bar of the Milky Way galaxy. But more specifically, this showed a direct connection to a star-forming region at the edge of the bar, which seemed to be responsible for the formation of these bubbles. In other words, this actually confirms that it was not from the black hole, it did come from a star-forming region, but not in the center of the galaxy like we previously thought, and instead at the edges of the galactic bar. And that by itself is a really important discovery. Actually, a somewhat unexpected discovery, because it tells us something about galaxies like the Milky Way we've never known before. It essentially confirms that it's not just the active galaxies that can actually produce these bubbles or produce outflows, it's also quiet galaxies like the Milky Way. But in this case, all of these outflows are just the result of star formation in an extremely specific region that was actually discovered not so long ago. And so this seems to be a phenomenon very common to various Milky Way-like galaxies, or essentially spiral galaxies that contain a galactic bar. And it's also a phenomenon that potentially explains how these galaxies grow in size and how they develop over time. Although interestingly, all of these magnetic fields are extremely well organized and seem to form these very thin filaments we've never seen before. And so it's actually these unusual long filaments of magnetization that reveal the origin of these bubbles by basically pointing at the source of the emission. And in terms of actual size, these are huge. Apparently, if we could actually see them, they would be approximately 150 times larger than the full moon. But because this is only visible with radio light, we're not going to be able to see them without specialized telescopes. But basically, this solves the mystery of Rosetta bubbles. They're not from a black hole, they seem to be from a starburst region at the outskirts of the galactic bar, which is actually not that close to the center, maybe 10 to 16,000 light-years away from the central black hole. But then, on top of this, a separate study, once again somewhere right there in the description, also revealed that the galaxy itself seems to contain huge magnetic toroids. And toroids really large in size, anywhere from 6,000 to 5,000 light-years away from the center. And these toroidal magnetic fields, which are obviously still very mysterious and still not very well understood, would also very likely influence the galactic motion and various physical processes, including star formation. Although in this case, this was discovered by looking at pulsars. By studying polarized light passing close to various pulsars, scientists whose paper you can find in the description essentially created a magnetic map once again, discovering that the magnetic fields here seem to actually form a toroid that we do expect from basically any magnet, which by itself is quite impressive. But apart from magnetic discoveries, there have also been some discoveries in regards to the galactic history and specifically various galactic collisions. And so essentially scientists discovered signs of galactic collisions or some other phenomena that seem to have affected the shape of the Milky Way galaxy. And here once again most of this came from the data from the Gaia telescope. And the most important discovery here, in my opinion, is actually this. The so-called Great Wave. And so in essence, the study by Poggio and his team discovered a really bizarre wave that seems to warp the galaxy in some way and seems to represent some kind of a major collision or some kind of a major event that happened billions of years ago. Now we don't actually know exactly what this is. It could be a galactic collision or maybe something else entirely. But here once again, by looking at the data from the Gaia telescope that analyzes the motion of stars, and by comparing data from 16,000 young stars and also 3,400 Cepheid variables, they essentially discovered that many of them were oscillating as if they were moving along the wave. And not just some kind of a small wave, but a wave whose peak is approximately 650 light-years in height, with a wavelength of about 10,000 light-years. And the wave that seems to be moving away from the center of the galaxy toward the galactic outskirts. And though previously we've discussed something known as the Radcliffe wave, an unusual wave-like structure extremely close to the solar system that was discovered not so long ago, in this case we're talking about something way larger, way more extreme, and something that seems to be across the entire galaxy, which is why it's referred to as the Great Wave, most likely a result of a galactic collision or interaction with some kind of a dwarf galaxy such as Sagittarius dwarf. A massive galaxy that the Milky Way has interacted with for billions and billions of years. But in that sense, it makes our galaxy look like some kind of a rippling pond, as if something dropped in the center, which essentially formed waves propagating in different directions. But it's obviously not entirely certain what's happening here yet, and we'll most likely know more in the next few months. So, subscribe and stuff, because we'll talk about this again. And then on top of this, we have a separate discovery in regards to various stars around the solar system. Here scientists analyze 800,000 stars approximately 3,000 light years away from the Sun, surprisingly discovering that the vast majority of all of them were actually pretty old, over 10 billion years old on average, with some of them as old as 13 billion years old. And that's actually a little bit unusual because it suggests that the majority of stars in the galaxy were potentially formed much earlier than we thought, with the galaxy itself maturing really quickly and very likely having some kind of a super intense star formation in just the first few billions of years. And so here the discovery is that our galaxy seems to be also much older and potentially developed pretty quickly, basically in the first billion years after the Big Bang. And the fact that the Sun seems to be orbiting in this region is also kind of difficult to explain. So basically our Sun, which is 5 to 6 billion years younger than these stars, seems to be a kind of an outlier. But then another intriguing study that essentially analyzed these so-called wrinkles in the galaxy and various wrinkles that form as a result of galactic collisions, researchers once again discovered something nobody expected. Here they surprisingly found somewhat recent wrinkles potentially produced in the last 3 billion years. Or to rephrase this, they basically discovered signs of a relatively recent collision, mostly because of unusual motion of stars that implied a collision 3 billion years ago. And that's actually 5 billion years later than previous assumptions. So even though previously researchers believed that the last collision was 8 billion years ago, the research here suggests otherwise. It was potentially 3 billion years ago, with many new stars added at the same time, which is the only way we can explain such an unusual motion, with the scientists now referring to this as Virgo radial merger, something that must have happened 2.7 billion years ago, and something that very likely brought a lot of other dwarf galaxies, which eventually became various star clusters. But exactly where they are and exactly what's left of them is still unknown. At the moment we just see the motion of stars. And so essentially these were some of the main discoveries from the Milky Way galaxy in the last few months. Hello wonderful person, this is Anton, and in this video we're going to discuss some of the new discoveries in regards to where our galaxy, the Milky Way, is headed. And I guess more specifically, we're going to discuss a relatively new study that identifies an enormous galactic structure that the Milky Way galaxy seems to be a part of, while at the same time explaining a little bit more about why our galaxy seems to be moving toward a mysterious point known as the Great Attractor, and also helping us visualize what all of this kind of looks like. But once again here we have to start with a bit of a history going back approximately 10 years. And so in 2014 there was actually a somewhat intriguing and somewhat groundbreaking discovery that our galaxy, the Milky Way, along with all of the nearby galaxies, and specifically all of the galactic clusters near us, seems to be a part of something much larger. By using some of the earlier catalogs observing various galaxies, and specifically observing their redshifts, back in 2014, researchers discovered that the Milky Way galaxy was a part of a region called Laniakea supercluster, with this image representing this supercluster and published by many different press releases at the time. The red dot, that's us, that's the Milky Way. Although in this particular image we're not actually looking at the structure itself, we're just looking at the motion of various galaxies, representing, as you can see, a kind of a galactic flow. A much better image is right here that actually shows us individual clusters and individual groups of galaxies, including the local group where all of us are located. But in essence, Laniakea represented approximately 100,000 different galaxies, all gravitationally connected and all moving in a certain direction. At least that was the discovery 10 years ago. But in some of the follow-up studies, including some of the more recent studies, researchers realized that it might be possible that Laniakea is not actually gravitationally bound and something else might be in control, and specifically, it might actually disperse and eventually become something else entirely in the next few billions of years. Nevertheless, the discovery itself and the techniques used here essentially started a kind of a new search, an attempt to conduct additional surveys and to use additional simulations in order to discover a complex network of filaments, clusters, sheets, voids, and everything that's inside of them that essentially forms the mysterious cosmic web. The still mysterious, enormous structure that seems to stretch across the entire universe, and that seems to have been created as a result of initial quantum fluctuations during the early stages of the cosmic inflation. You can actually check out one of the previous videos in the description that talks a little bit more about how all of this works, but in essence, when the universe expanded, because of the quantum fluctuations, it formed these initial overdensities that then eventually formed the cosmic web. At least that's the current story, and right now there does seem to be quite a lot of evidence for all of this. But in order to understand exactly how this looks, and more importantly, how all of this affects our relatively tiny galaxy that's just traveling inside of this particular web, we obviously have to try to figure out what all of these enormous structures around us kind of look like. And that's basically what this new study was trying to accomplish. Here, by using nearly 40,000 groups of galaxies, with one of these groups basically being the local group, by using new observations from different recent surveys, scientists combined the redshift with the distance to various galaxies in order to essentially figure out where everything was moving once again, and in order to establish the overall density of everything around us. You can actually even see some of these locations that form this intricate cosmic web in this particular video. And so in this study, Dr. Vlad and his team essentially conducted one of the most complex simulations using a compilation known as Cosmic Flows 4 in order to help us visualize everything around us. And as you can see, the images and the videos look absolutely incredible. The Milky Way, by the way, is right in the center. And well, here, one of the primary discoveries was once again that Laniakea might not actually be our superstructure after all. Or to be more specific, it's actually just a part of a much larger structure, all connected into something absolutely ridiculously massive. In other words, Laniakea in this case is just one of the smaller limbs. And so by using details of millions of different galaxies around us, one of the first discoveries was that Laniakea, and obviously the Milky Way galaxy, were actually all moving in a certain direction. In other words, there was another what's known as a basin of attraction, BOA for short. And we know that the Milky Way galaxy, and actually all of the galaxies around us, are moving toward it. The only problem is that it's actually located behind the galactic bulge, so it's extremely difficult to figure out what's there. Because all of this dust is blocking the view, this region is extremely difficult to study. Scientists refer to this as ZOA, zone of avoidance. But inside of this zone of avoidance, we've always known about this one particular region referred to as the Great Attractor. You can actually learn about this in some of the videos in the description, but in essence, it's a point where everything around us seems to be moving toward. A mysterious point that potentially produces a lot of gravitational pull, or, much more likely, a location along the cosmic web where a lot of galaxies around us seems to be flowing toward. Or essentially it's a kind of a downstream inside one of the networks of the cosmic web. But in this new study, scientists discovered something else that's even more intriguing. Turns out that even the Great Attractor and everything around the Great Attractor seems to be moving toward the same location as well. In other words, the flow does not stop at the Great Attractor, it just keeps going. And so all of the structures you see right here, including the humongous Laniakea, along with all of the additional groups, seem to be kind of attracted towards something else. And so intriguingly, Laniakea and all of the galaxies in it seem to be actually headed toward what's known as Shapley supercluster. And specifically the location scientists now call Shapley BOA, Shapley Basin of Attraction. And Shapley supercluster has been known to us for a very long time. It's essentially the largest concentration of galaxies in the nearby universe that seems to be at least 650 million light-years across. But because Shapley supercluster appears to be moving in the same direction as Laniakea, and they all appear to be moving toward the same point, this basically suggests that all of the galaxies inside Laniakea, including the point known as the Great Attractor, seem to be moving toward Shapley supercluster and some kind of a point inside of it. Now, I guess we can call it a Shapley Great Attractor. Which basically means that Laniakea is just a much smaller part of the much larger cluster, or just to rephrase this, the Milky Way is part of the Shapley supercluster as well, which in total encompasses over 700 million light-years of galactic space, and thus form one of the largest structures out there, but not the largest. As a matter of fact, one of the additional discoveries in the study is essentially other superstructures and their overall map. And amongst these newly identified regions, one of them really stood out, the so-called Sloan Great Wall. It seems to be the largest basin of attraction currently known to us, and as you can see from this simulation, is definitely much larger than Shapley and Laniakea together. But here you can actually see some of the other structures as well, which in essence creates this beautiful three-dimensional map of enormous superstructures traveling in outer space, following the mysterious cosmic web, making this a really impressive achievement and a really beautiful image. And because here we're talking about space billions of light years across, it's obviously somewhat difficult to put this in a perspective, because here we can't even see the Milky Way galaxy. Forget about seeing planet Earth. But importantly, this new study provides us with a completely new look into the gravitational landscape of the nearby space, showing us how various galaxies and cosmic structures evolved over time and very likely will continuously evolve for billions of years. It also kind of reshapes our understanding of the cosmic flow just a little bit, while also revealing extremely massive structures we've never really imagined, and the enormous influences they have on galaxies around us, just because of the sheer amount of mass involved. Although in this case, once again, this only focuses on the overall motion of galaxies. In other words, what you're seeing right here is a structure formed through densities of galaxies as they move across outer space. As a matter of fact, the galaxies on the outskirts here, technically, because of the expansion of the universe, are moving away from us at 30,000 km per second. But in this particular simulation, it's very difficult to imagine any of this, and so even grasping at what we're actually looking at here is a bit challenging. But it definitely looks really cool and somewhat artistic. I mean, this is real art, the art of the universe. Although when it comes to understanding the actual map of the universe, I think this here presents us with the best visual representation. Here this shows us the distribution of these basins of attraction and various loosely connected superstructures that hundreds of thousands of galaxies seem to form as they travel in the cosmic web. But because all of this also shows us how the universe will most likely evolve over time and how many of these structures will change as well, I'm sure in some of the future studies, researchers might even be able to predict where all of this is going to end up in the next few billions of years, eventually helping us answer questions about the eventual fate of the universe and of course the fate of our galaxy as well. But it's also important to remember that this only represents a part of the universe, roughly around 1 billion light years away from planet Earth. And since the observable universe is much larger, with time this picture will probably expand as well. In other words, the distance from the Milky Way to the edge observed here only represents like 2% of the observable universe. And so these are the largest nearby structures, but not the largest structures in the entire universe. But I guess the biggest takeaway from the study is just the fact that we now kind of understand why the Milky Way galaxy is moving toward the Centaurus constellation and why something like the Great Attractor even exists. It essentially represents a body of attraction, or a kind of a central gravitational point, toward which millions of different galaxies all seem to be moving at the same time. There's probably nothing specific there, but it all seems to be connected to the flow of galaxies inside the cosmic web. So in some sense, it's like moving down the stream on a river, with the river itself potentially connecting to something else eventually. Exactly what though, we still don't know. Mostly because, as I mentioned, it's just really difficult to observe this region. Hello info person, this is Anton, and today we're going to discuss a relatively new discovery coming from, I guess you would call it, cosmic neighborhood. A discovery of yet another terrestrial planet, but this time super close to us. A planet around a very famous star known as the Barnard star that's technically one of the closest objects to the solar system. And so let's talk about this in a little bit more detail. But here first, let's talk about why this is actually a super exciting discovery for a lot of astronomers out there. And that's despite the fact that thousands of planets have already been confirmed, and a lot more exciting planets have been discovered in a lot of other star systems. And so here, let's start with a bit of a history. And I guess let's start with the name first. Why Barnard star? Well, it's named after this guy, Edward Emerson Barnard. Barnard? I don't know, it's one of those names I've only read, never heard pronounced by anyone, so I'm going to assume Barnard. An American astronomer who back in 1916, or essentially 108 years ago, discovered an unusual star moving really fast in the night skies. or at least fast compared to other stars. It basically had a relatively high proper motion, moving laterally at 90 km per second. And because he was the first to discover this, and because this was actually before any star naming convention existed, this somewhat dim red dwarf eventually became known as the Barnard star. And because this guy was pretty prolific in discovering other things, he actually has a bunch of other objects named after him, even a galaxy. But one of the main reasons why this star was actually kind of exciting for a very long time is really because of its distance to us. This is, as I mentioned, one of the closest objects to us. Now Proxima Centauri is a little bit closer, Alpha Centauri as well, but then we have the Barnard star. Currently, it's only about 5.96 light years away from us, and it's essentially one of the closest objects ever discovered. Intriguingly, it was even discovered before Proxima Centauri. But both Proxima Centauri and Barnard star represent the closest red dwarfs to us. And as you might already know from some of the older videos, one of which is in the description, a while back, two separate planets have been officially confirmed around Proxima Centauri. One of these planets is extremely similar to Earth in terms of size and mass, and is also in the habitable zone. And so because of that discovery of Proxima b, and because of previous studies suggesting that many red dwarfs should have planets in habitable zones, the next obvious target has always been Barnard star, more officially known as Proxima Ophiuchi, which led to an extensive search in the last few decades. And there was actually one important reason why Barnard star was a little bit more exciting than Proxima Centauri. Proxima Centauri is what's known as a flare star. It's basically a red dwarf that's still kind of active and tends to produce massive flares, emitting a lot of X-ray and ultraviolet radiation that within just a few million years can actually strip any atmosphere and destroy any liquid water on pretty much any planet. And it just so happens that many red dwarfs turn out to be this. They're just a little bit too active for any life to survive on the surface. But when studying Barnard star, researchers discovered that it seems to spin really slow, and thus its age is much higher. In other words, Barnard star was potentially much calmer, and because its age was established to be 7 to 12 billion years, and because it was one of the older red dwarfs out there, it was assumed to be calm enough to potentially have hospitable conditions for terrestrial planets. But there were two problems. First problem was that initially no planets have been discovered here, and a second problem came in 1998. Despite being an ancient star, it experienced a massive stellar flare detected in 1998. And once this flare was discovered, the star officially became a flare star as well. With all this confirmed in 2019, when two additional ultraviolet flares were detected as well, with a total energy released being much higher than anything our sun produces during a typical very active stage. And so by observing these flares, researchers eventually calculated that a typical planet orbiting around the star would probably lose one Earth atmosphere every 10 million years, which obviously suggested that this was not a star for habitable planets. But still, researchers wanted to find something, anything. Basically, where are all the planets? And the thing is, since the early 1960s, there have been a lot of arguments for the existence of planets in the system, specifically gas giants. And so actually, as early as 1970s, several astronomers, including Peter van de Kamp, argued for the existence of some kind of a gas giant that was potentially detected using initial observations. But here this was detected by using extremely early and very inaccurate techniques using what's known as astrometry, or basically observing tiny deviations in motions of a star as it travels across the night skies. But back in the 60s and the 70s, astrometry was at its infancy and was basically very inaccurate. And so it didn't take long to basically disprove this idea, eventually proving that there was no gas giant here at all, and the star was not wobbling as much as initially assumed. Here's actually a really cool image showing us how the star compares in terms of size to Jupiter and to our Sun. But then, in November of 2018, a new study using new techniques revealed a potential super-Earth, or basically a planet a little bit more massive and a little bit larger than planet Earth, orbiting at 0.4 AU away from the star. And here this was detected by using a different technique known as radial velocity, essentially by observing the wobble of the star, but this time through the observations of the redshift and the blueshift coming from the starlight itself. But turns out that these observations were maybe not precise either, because by 2021, or approximately 3 years later, This signal was discovered to be not coming from the planet, but very likely from the stellar activity and just from the star itself changing in color by just a little bit. So basically it seemed to be some kind of a variable star effect and not really a planet at all. This is not the first time such a discovery has been made, and not the first time variability of a star fooled us into thinking it was a planet, with additional studies in 2022 confirming that this was not a planet after all. And so basically, in the last 5 decades, lots and lots of papers came out trying to find something here and discovered absolutely nothing. And this was super unusual because, as I mentioned previously, modern theories predict at least a few terrestrial planets around most red dwarfs. So what's exactly happening here? And interestingly, in the last decade or so, a lot of detailed observations revealed that there was possibly nothing here as far away from the star as a 1,000-day orbit. At least nothing comparable to planet Earth or larger in mass. And there was definitely nothing in the habitable zone that could have been similar to planet Earth, like in the Proxima Centauri system. And then, a few hours ago, from when I'm making this video, I got an email saying, "Attention, embargo, don't talk about this until, today basically." And that's because something finally has been discovered here, but we were not supposed to talk about it until now. And so let's talk about this new discovery that seems to be super official and definitely there, because in this case, the actual evidence seems to be very strong. Now, usually when I get these embargo emails from the European Southern Observatory, it's because something big has been discovered and they just want all of the press to talk about this at the same time. And normally you can actually get these emails yourself if you subscribe to their newsletter. But this time it was really the study itself and the amount of data included in the study that was kind of exciting. Now, as always, you can find the study in the description below, but here the title says it all. A sub-Earth mass planet orbiting Barnard star, discovered using ESO's extremely accurate and very precise Espresso instrument and HARPS instruments in the Lascaux Observatory. And one thing these instruments do really well is basically this. They can do radial velocity with absolutely unprecedented accuracy. In other words, they show us how something wobbles around something else by observing redshifts and blueshifts, but this time with accuracy we never had before. And these instruments are relatively new, they've only been operational for a few years, but we know their accuracy is very high. And well, this time the focus was Barnard star, because here astronomers just really wanted to find something, anything. I mean, like, please, because it just doesn't make sense that there would be nothing here. And well, eureka! There was something after all. And the reason it was invisible before was because it was just not massive enough. It is a terrestrial planet, but as the title suggests, it's a sub-Earth planet. And so here, by looking at signals from the habitable and the temperate zone of the Barnard star, they discovered and then confirmed a planet very, very close to the star. A planet that orbits every 3.15 days and very likely has a temperature of about 125 Celsius. So definitely hot and definitely too close for any habitable conditions, but still super exciting. And actually exciting for maybe one more reason. This seems to be one of the lowest mass terrestrial planets ever discovered, with a mass equivalent to approximately half the Venus, and specifically approximately 0.37 masses of planet Earth, which is surprisingly 3 times the mass of Mars. And it seems to have a perfectly circular orbit, visible in the way the star wobbles. But obviously, because it's so close to the star, it's unlikely to have any atmosphere and unlikely to have habitable conditions. But still, we finally found one planet here, and it's, as predicted, a terrestrial planet. But what's even more interesting, this new data suggests that there might be actually 3 more planets hiding somewhere in the vicinity, specifically orbiting slightly farther away, with maybe a period of 4 days, 2.3 days, and 6.7 days, with additional planets potentially being even smaller. And so in other words, one of the explanations for why no planets have been discovered previously is because they seem to be kind of tiny, much smaller than Venus, a little bit bigger than Mars, and basically Mars and Mercury-like in appearance and potentially surface conditions. And so along with the discovery of Proxima b and Proxima d, this once again confirms that there seem to be a lot of terrestrial planets near us, and quite a few of them are very similar to what we have in the solar system. Although in this case, in this particular study, they once again also confirmed that there seem to be no gas giants and no additional super-Earths as initially reported in previous studies from 2018 and from 1970s. And because here the observations were ultra accurate, it's extremely unlikely that this is a mistake. But I guess only time will tell what else we discover in this system, and more importantly, what sort of planets these are, what's on their surface, and if any of them contain conditions necessary for life to survive. And this is one of those stories that's once again going to be kind of rewriting textbooks. But not because something groundbreaking was discovered. Instead, this is something a little bit more intriguing and a little bit more fascinating. We're going to be talking about Neptune and Uranus, with a recent groundbreaking study definitively establishing that all this time we were kind of incorrect about the color of Neptune. But not because it was recently measured to be different, or because the telescopes got better and so we see more. Instead, this is actually a kind of a story of how, as humans, we process information over time and how we tell stories to each other, eventually influencing our understanding of everything around us, including facts and even scientific facts that can be misconstrued over time, and not because someone lied or because of some kind of a fake news phenomenon, instead a result of people not reading a side note and focusing on the visual presentation, taking it as a scientific fact. And so, hello wonderful person, this is Anton. Today we're going to be discussing this relatively recent study that once and for all determines that, yeah, Neptune is actually not the color we always thought it was. Here's actually one of the recent images released by Hubble from just a few months ago. And it does not really look like this at all, with all of the images presented in the last few decades sort of being really exaggerated and not really showing us the true colors. And really because it formed, I guess, a kind of a trend without anyone ever checking if this is really correct. And also because a lot of digital cameras used on a lot of different telescopes very often just send us digital data that then has to be reconstructed by scientists in order to make visual sense out of everything. And though for many planets like Jupiter, we basically know that it doesn't really look like this, and this is more of an artistic representation combining different frequencies including infrared into one. Or here's one with the ultraviolet light, for comparison. With Neptune and Uranus, the story is entirely different. And here I actually wanted to start with one of the videos you can find in the description that talks about a relatively recent study from 2022 that tried to explain why Neptune and Uranus look so different despite extremely similar composition and even relatively similar distance from the Sun. And the focus here was on colors only. And just to summarize that video, essentially it was all because of the distribution of different hazes or different types of molecules, such as for example ethane and ethine, and even things like methane, that seem to make Neptune just a little bit darker. And according to that study, Neptune basically just has an additional layer with a lot of methane condensation that makes it look different. And though by itself the study is definitely still correct and does present us with a really good explanation, what's intriguing here is that it was all based on misconceptions about the true colors of these planets. And so how exactly did all of this start? Well, it all started back in the 80s. NASA's Voyager 2 probe, that was launched back in 1977, collected a lot of imagery from all of the gas giants, and that of course included Neptune and Uranus. But the images for Neptune and Uranus were taken in two separate color bands. And when the probe sent back the data to planet Earth, the researchers processed them in slightly different ways. Here's for example raw data from the James Webb Space Telescope of Neptune in infrared light. And so these initial images looked somewhat similar. They didn't really have a lot of color in them. But when the images were released to the public, they were processed in a way to emphasize the colors for Neptune, and specifically by deepening its true colors, making it appear a lot more blue. And though Uranus was published in its true colors, the images for Neptune were a little bit more dramatized. They were enhanced to make them look slightly different. Now it's not entirely clear why this was done, but it was probably to present these two planets as basically different. They did look extremely similar initially. This is of course what these images looked like. And so a lot of this blue color in Neptune is technically artificial. But intriguingly, this was not a deception. As a matter of fact, there was a side note. A tiny caption explaining that the Neptune's colors were enhanced and did not represent reality. But who reads captions anyway, right? I mean, maybe you do and maybe I do, but over time, this tiny side note has been completely lost, with Neptune becoming bluer and bluer over time. And here's how blue it looks in the Hubble images from 2021. Now once again this is enhanced to make it look slightly more dramatic, but at this point the scientists working on this basically thought that this is indeed what it might look like, and they just had to bring up the colors to make it appear as Neptune should appear, making this an extremely interesting example of misinformation spreading over time and technically becoming scientific fact. As a matter of fact, I'm pretty sure in most textbooks that have Neptune in them, it's going to look just as blue. So if you're still at school, or if you have a child at school, I guess get one of those whiteouts and start spreading the colors, making it look as it really should look. It should be extremely similar to Uranus. And here's a fun fact. When I was making this video, I went on Wikipedia and guess what? All of the major images for Neptune have been correctly changed to represent the true color. It even says this in the captions. Even this iconic image that compares Neptune to planet Earth has been changed to reflect the reality. And this is indeed what Neptune looks like. Extremely similar to Uranus, actually let me show you the comparison, and practically indistinguishable from the other ice giants. In contrast, this is what it sort of looked like just a few months ago. So yeah, this is a huge difference. But all of this came as a result of a recent reconstruction of these original images by essentially using additional data from the Hubble Space Telescope and the data from the Very Large Telescope in order to reprocess images once again by focusing on true colors as opposed to enhancement. And so these new images show us Neptune as much lighter and definitely not blue, but still a tiny bit bluer than Uranus. Once again, you can sort of see this in this image. And that's of course related to that study from last year in regards to the methane condensation in the atmosphere of Neptune, or basically a tiny thin layer of various types of hazes in the atmosphere that shift the colors just a little bit. Although here these new observations also tell us a little bit more about Uranus and why this planet changes colors slightly over time, specifically over the period of its year which lasts for 84 Earth years. Because the planet orbits on its side, the effects from the sun tend to change the poles of this planet, making them appear slightly greener. But during different seasons, when different parts of the planet face the sun, they shift to appear a little bit bluer. And so basically the changes in color on Uranus, not on Neptune, are entirely due to its orientation as it orbits the solar system. So once again, this planet orbits on its side, and here is roughly how it changes over time as viewed from planet Earth. This shows us the change over a period of approximately 45 years. And the main explanation right now suggests that it's very likely because of methane once again. There's more methane on the equator than in the poles. And this changes the way Uranus reflects light. Since methane absorbs red light, it basically reflects green light, making Uranus appear a little bit greener at certain times. But this does not happen on Neptune, because Neptune does not spin on its side. And at the same time, there's something else Neptune has that Uranus doesn't: clouds and different types of storms. Now, interestingly, the clouds on Neptune seem to have disappeared for now, although it's currently unknown why, but it's most likely some kind of a seasonal change. But more importantly, Neptune's atmosphere has a lot of active storms. Here's an example of a very famous Great Dark Spot, something that seems to be dynamic and changes over time and sometimes disappears. Now, both Jupiter and Saturn also have different types of storms, but for some reason Uranus doesn't. And so despite similar colors, these are still very different planets. Neptune even has unusual hot spots in its atmosphere where the temperature can be up to 750 Kelvin. This cannot be coming from the sun, and so it has to have some kind of a different origin. Previous studies suggested that it's probably some kind of an aurora or some kind of a magnetic reconnection, but the real reasons are still unknown. Which means that there is still so much to learn about both of these planets, and someone should definitely consider launching a mission to either one of these planets or maybe even both planets at some point in the future. Here's another interesting image of Neptune in the infrared light, showing us the clouds as they change over time. This was actually taken just a few hours apart, and so the atmospheric activity here is quite extreme. And so in conclusion, all of this reinterpretation was because of this study. And all of these previous images that showed Neptune as much bluer, in essence were kind of incorrect. Here's one of the more extreme examples that really shows this planet as super blue, which it definitely is not. And so since we've been actually finding a lot of these Uranus and Neptune-like planets out there, in a lot of different star systems, understanding the true colors of these planets and what's happening in them is also important for a lot of exoplanetary studies as well. And so next time when we hear Neptune-like planet, we shouldn't really imagine this as much as this. So yeah, definitely important, and definitely a really interesting example of how a tiny side note can be lost in time and eventually lead to a complete misrepresentation of real scientific facts. And in this case, even a lot of NASA scientists seem to have forgotten about this. But luckily, after a few decades, someone caught the mistake and now we have the true picture. Looks like we finally solved the mystery of orcs. Oh wait, sorry, this video is from my other channel, the fantasy channel with Anton Petrov. And let's try this again. Looks like astronomers might have solved the mystery of orcs, these types of orcs. The phenomenon known as odd radio circles. And this is really exciting because this unusual phenomenon was discovered completely by accident back in 2019, or essentially just over 4 years ago, and back then nobody had any idea what exactly this is. These unusual radio phenomena appeared as circular objects out there in the universe, with no apparent explanation for what exactly caused them, and not even hints on their actual size. They could have been just a few thousand light years across, or they could have been a few million light years across. And so, hello wonderful person, this is Anton, and today we're going to be potentially finally solving the mystery of orcs based on a recent study that explains their origin relatively well, or at least explains half of them. And so let's discuss this in more detail, but I guess let's start with a bit of a history and how this mystery was born. Now, their original discovery was really the result of new advancements in radio telescopes, and specifically the ones in Australia. This is what's known as ASCAP, Australian Square Kilometre Array Pathfinder, that was upgraded a few years ago to basically become one of the most powerful radio telescopes ever. And so the researchers that were collecting data using this brand new telescope, completely by accident, discovered unusual faint signals in different locations around the universe. There were actually quite a lot of discoveries around this time, and we've discussed some of them in the description, but most of them were relatively easy to explain and did not involve completely new phenomena. But these strange circles definitely were unusual. First of all, they appeared to be enormous, potentially larger than any galaxy near them. And 3 of them contained galaxy in their center as well. But more interestingly, nothing was visible here in the visible, infrared, X-ray, gamma ray, or basically any other light, suggesting that these were uniquely radio phenomena, which by itself was really strange because normally, if we see something in radio light, we normally see something else in other frequencies as well, with the implication being that this was a physical process that's uniquely produced by what's known as synchrotron radiation. In essence, radiation usually produced by various particle accelerators, or when electrons move through magnetic fields, or sometimes close to really massive objects that change their acceleration. And this is basically produced when very fast-moving electrons change their velocity suddenly for one reason or another, be it magnetic fields or extremely strong gravity. And so this was one of the main implications from these unusual circles, which sort of provided some hints for what these circles could be. And because 3 of these orcs also had a galaxy right in the middle, it kind of suggested that the galaxies most likely formed them through some really powerful process involving massive emissions from the center. And so in order to try to answer these questions, the researchers, whose paper you can find in the description, decided to focus on Orc 4, essentially the first orc that was discovered that, as you can see, does have a central galaxy as well. Now, initially when the scientists were trying to understand what's going on here, because this was a circular object and because it involved very powerful emissions, initial explanations varied from extremely powerful mergers of central black holes, ultra-powerful supernova, or potentially planetary nebulae that are actually much closer to us but have never been seen before. And though these ideas still kind of make sense, there was really no evidence for any of them because no other frequencies are visible here, even though they should be visible based on these propositions. But by observing Orc 4 using a spectrograph on top of the WMCAC observatory in Hawaii, the researchers were able to see additional detail that was previously invisible. Here they saw extremely bright, extremely hot compressed gas in much larger quantities than in a typical average galaxy. And by using a combination of optical and infrared data, they were able to determine the average age of stars inside the galaxy in the middle. The age here seemed to be about 6 billion years, with all this being the first hint for what most likely happened here. But to test their idea, the scientists ran computer simulations replicating the size and properties of the unusual ring, which actually included all of the gas that seems to be there as well, in the end providing a very good explanation. Actually, most likely, the explanation we were looking for since the beginning. With the simulations producing these very powerful outflowing galactic winds that were most likely blowing for approximately 200 million years before the starburst activity finished and the galaxy became quiet again. And so when this wind stopped, even though some of the gas was still moving away from the galaxy, which ended up creating the radio ring, at the same time there was also a kind of a reverse shock that suddenly sent a lot of gas back into the galaxy, which is what we're observing as well. And all of this very likely took approximately 750 million years since the beginning of the major outburst, with the total age of this unusual object being about 1 billion years in total. But in order for this phenomenon to form, you do need a huge amount of outflow with a lot of material ejected all at once. And at the same time, in order to form these orcs, the gas outside of the galaxy has to be relatively low in density as well. Otherwise, the sphere is not going to grow much, and all of this is going to fall apart, which already suggests several things about these galaxies. First of all, they were most likely located in relatively remote regions without a lot of gas around them. But second of all, in order to initiate these very powerful emissions and outbursts, and in order to begin the starburst activity, they most likely had to experience a galactic collision of enormous proportions, possibly two large galaxies colliding together. And if this happens in just the right way, it pushes all of the gas into a relatively small region in the center, which initiates an enormous starburst activity, producing really massive stars that very likely only survive for a few million years, exploding in massive supernova that create even more outflow in the process. And it's really these repeated supernova that very likely produce this outflow coming from one of the regions in the galaxy. As a matter of fact, it's probably not even the center of the galaxy. It's probably just the center where all of the gas accumulates, creating a much higher density. We actually see very similar formations in much smaller examples, such as the famous antenna galaxies, which also involve two galaxies colliding. But I guess the question here is, why is it that galaxies like this one, the antenna galaxies, does not seem to produce similar odd radio circles? I mean, obviously maybe we're just not seeing them because they're much closer to us, but since only 6 such objects have been discovered so far, the real answer is probably something else, because chances are that these galaxies possess much higher rate of star formation than anything we've seen before, and end up producing a tremendous amount of supernova all at once. If enough explosions occur in the same region at the same time, it can easily produce outflowing winds with speeds of several thousand kilometers per second escaping the galaxy, with the overall pressure from the supernova pushing more and more gas out of the galaxy. And by also being located in a region with a lower density around the galaxy, this just makes things accelerate much faster at much farther distances. So basically these are just extremely rare galaxies with extremely powerful outflowing galactic winds. And that actually suggests that we can use orcs to potentially learn more about these winds in order to understand how galaxies evolve after a typical collision and how starburst activity changes them in the process. Basically here, by looking at these orcs, we can use radio data to analyze the winds over time. But for this particular study, the only reason that we're able to discover all of this is really because of that gas that seems to be falling back into the galaxy, cooling down in the process, with this cooling effect producing extremely faint visible light radiating from oxygen, which is exactly what the scientists were able to see around the galaxy and inside this odd radio circle. In essence, presenting us with an explanation for at least 3 of these objects. The other 3 don't seem to have a visible optical galaxy, or at least one that has been discovered yet, and so they might be a little bit more mysterious, at least for now. But chances are they're also caused by something very similar, and might actually provide us with even more data on how these starbursts happen in various objects, even smaller galaxies, and how galaxies evolve over time. But obviously there are some unanswered questions. For example, do all galaxies, all massive galaxies, go through this? So for example, are antenna galaxies going to be showing this as well, sometimes in the future? And if not, why not? Does this actually require some kind of a super powerful wind? And if so, how common are these winds, and why do they happen in some galaxies, yet not other? Likewise, is this going to happen to the Milky Way when it collides with the Andromeda? Our galaxy also seems to have relatively low density around itself, and we have these 2 galaxies on a collision course that's going to start happening in the next few billions of years. And so chances are that because of orcs and because of their association with galactic evolution and starburst activity, we might actually have answers to some of these questions as more and more similar studies are conducted about this, and as we learn more about what's actually happening here, and why we're not seeing more of these objects around us. There is something really fascinating about exploring the galaxy and exploring the universe by using various types of maps, or looking at the universe in different wavelengths just to see how things look very differently depending on what light you can perceive. And in the last years, I've made quite a few videos on various maps already created by scientists, and there are even several websites dedicated to helping us visualize all of this in order to understand the universe a little bit better. You can obviously find some of these videos in the description, but I think as of now, one of my most favorite websites that you can find in the description has to be Chromoscope. The website that allows you to see things, or specifically see the night skies, not just in visible light, but also helps you visualize hydrogen, helps you visualize different frequencies of infrared light, microwave light, radio light, X-rays, and gamma rays. The highest frequency of light, or the most energetic photons, we can detect from anywhere in the universe. And it just so happens that NASA has just released one of the most incredible videos showing us this entire gamma ray map as a kind of a time-lapse. A time-lapse lasting for 14 years. And it's honestly sort of mind-blowing. And so, hello wonderful person, this is Anton. Let's discuss this new video and what exactly this is showing us, what we kind of learned about this in the process, and of course understand why this is important and why the scientists are really fascinated with studying gamma rays using the Fermi telescope. Because in essence, this is exactly what you're seeing. You're seeing the observations from the famous Fermi telescope, the telescope responsible for discovering such iconic features as Fermi bubbles, named after the telescope. And in essence, this is showing us the biggest sources of the highest radiation in the entire galaxy, along with intergalactic sources that sometimes are so bright that they can actually overshadow everything. And one of the reasons the Fermi telescope is so important is really because we cannot see any of this from planet Earth. Our atmosphere blocks gamma ray radiation, and so we can only see this from outer space. And that's actually the good thing. You don't really want gamma ray radiation reaching the surface. It's a bit dangerous. And so back in 2008, NASA launched this beautiful telescope specifically meant to study all of this. And though it was only meant to operate for 5 to maybe 10 years, it's now been running for almost 16 years. In the process discovering roughly around 7,000 sources of gamma rays, with quite a lot of them obviously being very surprising, and quite a lot of them never known before. And though the Fermi bubbles are probably the most well-known example of what it discovered, in essence, most of these 7,000 sources were a big mystery up until a decade ago. But exactly what are these sources, and what are we actually seeing? Interestingly, if you go to that website I mentioned previously, the Chromoscope website, you can sort of compare how the gamma rays, X-rays, visible light, and so on compare to one another. You don't really see the same objects at all, or I guess almost at all. It's extremely unlikely to see the same object in all of the frequencies. I guess a good example is right there, Centaurus A galaxy. Easily visible in radio light, somewhat visible in microwave, but practically invisible in infrared or visible light, and just a tiny dot in gamma rays. And that's because the majority of stuff you see here, the I guess biggest yellow-orange line, these are not individual objects. These are extremely energetic gamma rays produced when various cosmic rays strike interstellar gas inside the galaxy itself, or in some cases strike the stars, or specifically the region around the stars, where a lot of these cosmic rays are then converted to gamma rays. And you can actually see that the gamma rays here generally coincide with the location of neutral hydrogen, or the location in visible light where there's a lot of gas hiding everything. And so this unusual yellow line that forms the Milky Way, that's basically the interaction of various cosmic rays with a huge amount of gas, with obviously some of them being individual stars as well. But quite a few additional sources, especially really bright sources, visible as tiny star-looking objects, are basically either neutron stars or, in many cases, extremely powerful galaxies. And specifically here we're talking about blazars, active galactic nuclei billions of light years away from us that completely by accident are aligned in such a way that their jet points directly at us. And so in this case, because we're staring at their jet, what we're seeing are, of course, various interactions of the central black hole with a lot of material around it and various flare-ups that occasionally outshine everything. But it's actually kind of difficult to see them in this perspective, and it's much easier to see them when you look at the second perspective provided by NASA. Here, every individual dot is literally some kind of an extragalactic object flaring up once in a while. And some of these blazars flare up so much that they become the brightest objects in the entire gamma ray sky, very often for several days. But intriguingly, this never lasts very long. They pretty much become almost invisible after a week, suggesting that this is of course the activity around a central black hole where things are extremely unpredictable. Not a lot of these blazars remain extremely bright for a long time. And here's actually some of the most famous ones studied by the scientists using Fermi. And here you can even see the distances, anywhere from a few 100 million light years to several billion light years. And you can easily see them from all of these distances. But blazars generally produce very long events that last for several days, possibly several weeks. But one event that's not visible here are gamma ray bursts. And we know that so many happen all at once, all over the place. The thing is, they only last for a few seconds or even less than a second, and so seeing them on this map would be almost impossible. They basically just blur with the background because this time-lapse goes really fast, with a single month only lasting a second. And so the most powerful emissions in this case are from blazars. As a matter of fact, 4,000 of these objects, or more than half of them, are various types of galaxies, very often blazars, around the universe. And it's actually these blazars that also produce cosmic rays that travel across the universe, interacting with gas and stars in various galaxies, which are then responsible for producing the glow you see right here. And then if you look closely, you'll see that there is something else here that's maybe a little bit unusual. The sun. You also get to see the sun. It's not actually visible all the time, but when it is visible, it's really visible. And in September of 2017, it produced one of the most powerful gamma ray bursts that brightened the sun quite dramatically. And this was a result of a very large solar flare observed around the same time. And though usually the sun produces gamma rays only through the interaction with various cosmic rays, in this case it's quite likely that it was the sun itself producing this burst. And so once in a while, a very powerful solar flare can also be responsible for gamma rays. And that's not really surprising because we even see gamma rays coming from Earth's atmosphere, in this case very often caused by lightning. These were also discovered by the Fermi telescope and they're known as terrestrial gamma ray flashes. Basically gamma rays coming from Earth, not from the sun, not from anywhere else. And you can learn more about this in one of the videos in the description. But for the majority of the time, our sun is extremely quiet and is barely visible in gamma rays at all. And will only produce a tiny amount of gamma rays through the interaction with cosmic rays. With the other unusual observation visible here being these unusual dips here and there, as if the galaxy is vibrating or breathing. And it's not really doing that. This is all just a result of Fermi orbiting the planet and observing things differently at different times. Because of the way that Fermi orbits the planet, its cone of observation is slightly different at different times of the year. And so we basically get to see slightly more stuff sometimes and slightly less stuff in other times, thus creating these unusual unequal parts. Although there is something that does actually change around 2018. Here the observations become slightly less accurate and slightly less vibrant. And that's actually because of the failure in one of the solar panels where the energy had to be redirected and the observations had to be changed just a little bit. And so even though the telescope still works, it is showing its age. Nevertheless, it's not being retired yet, it's still functioning, it's still going on, and will most likely keep observing the night skies for a very long time to come. So the mission is definitely far from being over. For example, not so long ago, it released new images of not just various blazars, but also various neutron stars, specifically pulsars, with hundreds discovered in the process. Here's roughly what many of them look like across the entire galaxy. And there are also thousands of different variable sources, and in some cases, their origins are not entirely known. And so for gamma ray scientists, there is still a lot of work to do and a lot to accomplish in order to understand what's going on in the galaxy, in the universe, and what's producing all of this very high energy light. Here's actually a really cool simulation NASA released just a few weeks ago, basically showing us 300 various pulsars producing gamma ray pulsations across the entire galaxy with very different periods. You can see this visualized by the way they change their shapes. And so some of them are extremely fast, some of them are kind of slow, and they do produce different energy levels as well. With this map showing us where they're located compared to planet Earth. And since so many modern mysteries involve gamma rays, for example gamma ray bursts, the interest for this type of research is not going to disappear anytime soon. We're going to be hearing about more gamma ray discoveries next year and the year after that, and we're definitely going to be talking about all of this in many videos in the future. But when it comes to this multi-wavelength observation science, this is basically as good as it ever was. We now have these super accurate observations in pretty much most frequencies, and we now are able to study the galaxy and the entire universe in a way we've never been able to see it before. Today we're going to be discussing a very unusual discovery, and actually a somewhat difficult to explain discovery, of a tremendously large cosmological structure. A structure so big that it shouldn't exist. But before we start, and before I explain to you what was discovered, let me actually just show you how tremendously large this structure would be. Honestly, I don't even know where to start with this, but okay, this is the Milky Way galaxy, roughly around 100,000 light years across. This is a Milky Way galaxy from roughly around 1 million light years away. This is a Milky Way galaxy from the Andromeda galaxy, approximately 2.5 million light years away. Now okay, imagine this, but 1,000 times bigger. So it would be very difficult to physically imagine this, but it would be something like this. And that's actually the size of the unusual structure that was discovered back in 2021, that the researchers referred to as the Giant Arc, an extremely dense galactic cluster that's basically connected into one gravitationally bound structure. If we could see it, it would look something like this, and it would be approximately 3.3 billion light years across. Discovered by a PhD student, Alexia Lopez, basically more or less by accident. And though it might not seem strange at first, it sort of violates what's known as the cosmological principle, the idea that the universe should be maybe a little bit simpler, and that it should be more or less the same no matter where we look. And more importantly, we sort of expect the matter to be more or less evenly distributed everywhere. And so we shouldn't really detect super large structures anywhere in the universe, at least for now. Things might grow larger and larger with time, but because the universe is only 13.8 billion years old, nothing larger than approximately 1.2 billion light years across should exist. This size limit was calculated based on our knowledge of the universe, and it was violated pretty quickly. Mostly because these large structures were discovered all over the place. But at first they weren't super large. Then in 2021, this giant arc basically beat the limit by 3 times. And there was no explanation for how this was possible or why these galaxies were gravitationally linked to one another. But naturally this discovery could have been interpreted in different ways. For example, maybe these galaxies are not really connected and are just aligned in this way completely by accident, or maybe this is just a result of something else we don't really understand very well, such as the mysterious cosmic web. Either way though, this was 2 years ago. But the main researcher, Alexia Lopez, along with her partners, did not stop looking, and actually discovered something else extremely recently that's even more exciting and more unusual. Although first, let me tell you how all of this was done, because it's also kind of important. Because unfortunately, by just looking into outer space, we're not going to suddenly start seeing these large structures or a connection between various galaxies unless we use specific techniques. And the technique here relies on quasars, galaxies with extremely powerful supermassive black holes in the middle that in essence emit a lot of light toward us, with light traveling for billions of years, sometimes almost from the edges of the universe. And today we know of a lot of quasars out there. A lot of them have been studied quite extensively, and here's actually just some of the new ones released by the Japanese scientists not so long ago. But the thing about quasar light is that it tends to pass through various objects, and as it passes through, for example, gas, it sort of changes the overall spectrum that's coming from the quasar itself. For example, it might pass through hydrogen or helium and thus produce certain spectra. And if you have enough of these quasars across the night skies, you can actually then start detecting a lot of invisible things, because the quasar light will pass through it and thus change its spectrum. And this is how scientists have been discovering a lot of things out there, especially things that might be a little bit difficult to see, such as gas potentially connecting galaxies to one another. And so by looking at specific absorption spectra coming from distant quasars, specifically using magnesium-2 absorption spectrum, here the researchers discovered that giant arc. But now they found something even cooler. They found a large donut, or I guess a large circle. Although at least for now it's referred to as the Big Ring. And as you can see in this case, it seems to be in a similar location, somewhat similar in size, although here the diameter is about 1.3 billion light years, and located at a very similar distance of about 9.2 billion light years away from planet Earth, making this the second such enormous structure located in the same region, and once again sort of beyond the expected limit. To some extent, once again, challenging modern cosmology. And once again, just to give you an idea of how big this is, if you were to look in the night skies, and if you were to look at the full moon, this structure would be at least 15 times larger. I mean, assuming you could actually see it. Here, because this is all galaxies and a lot of gas, it would be very difficult to see this in anything but maybe radio light. And even though both of these structures sort of create a major problem for cosmology, when put together in this location, they create an even bigger mystery or a bigger problem. There is absolutely no explanation for how they formed. Neither their shape nor size is easy to explain if we consider modern astrophysics. And since they're so close to one another, currently it sort of makes no sense. But there was one potential explanation for that big ring. It's related to the concept known as BAO, baryon acoustic oscillations. Essentially huge bubbles produced by density waves that modern cosmologists believe formed extremely early in the universe. And all of this was a result of gravity interacting with early matter, producing an equivalent of spherical sound waves in a very similar manner to what you see right here. The circular ripples produced by the rock falling in the water represent a very good symbolic analogy for this BAO phenomenon. And if you actually want to learn a little bit more about this, check out one of the videos in the description that actually talks about a recent discovery of an incredibly large structure very close to us that is potentially one of these BAOs. The link should be somewhere right there. And so anyway, these BAOs are predicted to exist, and they're expected to create circular shapes. And so maybe this is exactly what we have here as well. But the problem here is the size. This here is at least 3 times as big. And moreover, it does not appear to be truly spherical or truly circular. So it doesn't really fit this explanation very well. And if not baryonic oscillations, then what else could it be? Intriguingly, quite a few alternative cosmological models might provide certain answers. For example, one of the propositions by Roger Penrose is what's known as conformal cyclic cosmology. The idea that the universe might physically go through several big bangs, one after another, with a long period of nothingness in between them. In other words, he proposes that cosmology might be cyclical and big bangs might happen over and over. And there is a slight possibility that maybe this is one of these rings that could serve as the evidence for this. Way too early to tell, but it's a possibility. Alternatively, it could be some kind of a defect in the space-time itself. For example, what's known as the cosmic string. A kind of a crack in the universe itself that can actually form unusual observations from a distance. They've never been physically seen, but they have been proposed by a lot of cosmologists. And so some of these cosmic strings could force certain galaxies to be distributed in a certain way. And in this case, they might have formed a circle, whereas the other nearby string formed a long arc. But at this point, all of these are just speculations. The reality is that nobody knows what these are, how they formed, or what exactly this means for modern cosmology. Although one thing that's certain is that modern cosmology definitely cannot explain any of this. And so some things will have to change. And so even though just the sheer size of these objects was already difficult to explain, their proximity takes this mystery to a completely new level, with the overall distance suggesting that they must have formed when the universe was only about half its current age. And so this is not something that potentially existed from the beginning, but also suggesting that maybe even more similar objects will be found in the next few years. Because it seems that these structures are maybe a little bit more common than we thought, and so once the third such object is discovered, this is where we definitely have to start thinking about why and how this was formed. It's now been approximately 25 years since the discovery of the mysterious dark energy. The unusual phenomenon that was discovered back in 1998 by 2 separate scientific teams looking at 52 supernovae at various distances away from planet Earth. And by using specific supernovae, often used as distance candles, the Type 1a supernova, which usually produce relatively similar brightness, the researchers back then discovered that the universe seems to be not just expanding, it's actually accelerating its expansion, with things far away from us moving faster and faster and faster. And back then, this was such a groundbreaking discovery that back in 2011, it was recognized with a Nobel Prize, and so this was the official discovery of the mysterious dark energy. But instead of providing answers to the universe, it obviously created a lot more mysteries. So many, as a matter of fact, that today we're faced with several additional mysteries from all of these discoveries. For example, the idea of Hubble tension, where the expansion of the universe seems to be different depending on what data you look at, and of course, the mystery of the ultimate fate of the universe. What exactly is going to happen to everything billions and trillions of years in the future? And well, the thing is, we now have a new release of data and new analysis and several new studies that provide a lot of answers for everything. Hello wonderful person, this is Anton. Let's discuss this new analysis and new data release that doesn't just confirm the existence of dark energy, but actually tells us a little bit more about what's going on here, while also uncovering a few mysteries in the process, and more importantly, telling us a little bit more about the future of the universe and where it's all most likely headed. But here I guess let's start with a few basics, just so that we're all on the same page. So what exactly is this dark energy? In the past you may have seen a pie chart like this. Basically tells us that the majority of stuff in the universe seems to be this mysterious dark energy, and the baryonic matter, so things that we are made out of, only seems to be less than 5% of everything. But this doesn't really tell us the whole story. As a matter of fact, it barely tells us anything. You might have also seen a picture like this that shows us the evolution of the universe in the last 13.8 billion years. And the reason it's so conical is really because of this expansion of the universe, with this last part showing us the acceleration of the universe in more recent times. And this is actually a little bit more important when it comes to figuring out what seems to have happened in the universe billions of years ago. And so today, based on various observations from a lot of different telescopes, and by the way, this has been confirmed by pretty much every cosmologist out there, today the scientists established that there seem to have been three main stages of the entire universe, or I guess at least three. At first, everything was dominated by radiation, so basically everything was just pure energy. And only when the universe cooled down enough, that's when matter started to appear. As a matter of fact, for the first few thousand of years, everything in the universe was pure energy. But it did start to slowly convert into matter approximately 70,000 years after the Big Bang, eventually resulting in a new era where everything became dominated by matter and not energy. And around this time, this is also where we get the iconic cosmic microwave background. The point in time when the temperature dropped enough to suddenly allow electrons and protons to form hydrogen. And by this time, the matter was already more or less prevalent everywhere. But then, for billions of years, everything in the universe was dominated by matter. So obviously things like stars, galaxies and so on, and a lot of gas. And all of this lasted for approximately 10 billion years. But then something started to happen approximately 3.8 billion years ago, so more or less in recent times. This is also of course the time when Earth was already around and early life was already developing. Suddenly, the universe started to accelerate. Now, I was probably doing this even before this time, but 3.8 billion years ago, it really became difficult to ignore. And so these last 4 billion years, this is when the universe became completely dominated by dark energy. And that's of course that pie chart I showed you previously. Now, even today, nobody has any idea what this dark energy is or how to explain any of it, but it is estimated to make up nearly 70% of everything in the universe. And technically, it was also predicted by Einsteinian formula back in 1917. In his formula, this represents what's known as a cosmological constant. Now, he actually didn't believe this constant was real, and he even removed it completely, but hypothetically, his cosmological constant, if it is positive, could explain dark energy, at least in terms of mathematics, but not explain it physically or in terms of what's actually causing any of this. And unfortunately, we're not going to be getting these answers today either. But the scientists were able to discover something else in regards to an elusive parameter known as W. W in this case stands for the equation of state. Now, if you want to learn more about this, there's a neat link from NASA that describes this using gas equation as a symbolic analogy. But in a nutshell, previous predictions suggested that W should be exactly -1, which presents us with a universe where as dark energy increases, so does the negative pressure that pushes everything away. And the more dark energy there is, the more repulsion there's going to be, with all of the matter continuously expanding over time. Or in other words, it kind of suggests that if W is -1, the universe is just going to be continuously expanding pretty much forever. But a while back we've discussed an interesting proposition and an interesting study that provided evidence that this W value was maybe higher than 1, and thus the universe is not just going to be expanding, but it's going to be expanding so much that it will eventually rip apart. And this was the idea of the so-called Big Rip, the eventual fate of the universe where everything just sort of rips apart completely, disappearing in the process. One of the older videos in the description talks a little bit more about this, but this was a while ago and all of this was based on much older data. The thing is, now we have completely new data coming from these recent observations and recent studies, and specifically coming from this beautiful telescope you see right here, Victor M. Blanco telescope located in Chile. A telescope that's been used for over 10 years now as part of what's known as DES, Dark Energy Survey, a long and complex project whose main purpose is to try to map the entire universe, in the process discovering as much as we can discover about dark energy and pretty much everything else. And though it's already made incredible discoveries in the past that we've discussed in many previous videos, this time, after 400 scientists and 25 different universities collaborated, we finally got some of the most advanced data looking at various supernovae in roughly around 2 million different galaxies, with these galaxies containing thousands of active supernovae, and 2087 of them were type 1a, the supernova that we usually use as various distance candles in order to measure distances to different galaxies out there. And so by looking at these 2087 supernova and by measuring redshift to each of them, the scientists were definitively able to establish that first of all, the universe is definitely expanding, as you can see from this graph, and thus dark energy is definitely real, but more importantly, discovering the value for that W. It seems to be minus 0.8, which potentially answers what's going to happen to the universe. By having W less than 1, it basically means that the universe is not going to be continuously expanding, it's at some point going to slow down and potentially even start shrinking again. And if it shrinks more and more, it might even reach the state known as the Big Crunch. Basically, it goes back into a tiny point and maybe starts over again with another Big Bang. Although here we don't really have enough details about what's really going to happen, because the only thing we know right now is that it's most likely not going to be expanding faster and faster, and the universe is not going to end up in the Big Rip. But even more importantly, they've discovered hints that maybe, just maybe, the density of dark energy in the universe seems to vary with time, which would naturally explain the unusual phenomenon known as the Hubble tension. You can learn more about this in some of the videos in the description, and once again confirms that the modern models of the universe are definitely incomplete. Current models and current formula rely on a lot of constants and the universe that does not change that much in terms of properties. But these very accurate observations kind of suggest otherwise. And so the overall density of dark energy can potentially vary over time. Why and what exactly is happening? There's really no answer for any of this, or even mathematical formula to explain this, but the data does hint that dark energy changes. That's really all we know. And so this means that this simple model of dark energy that we have right now does not seem to work really well. And a lot of cosmologists already kind of knew that, just based on this idea of Hubble tension that just has no explanation at all. Nevertheless, the data is still very clear that the universe is definitely expanding, is definitely accelerating the expansion, and has been growing faster and faster for the last 4 billion years. But it also means that we have way more mysteries now than we had 25 years ago. And so even though back in 1998, with just 52 supernova, scientists discovered hints of this, now with 2000 supernova, it's pretty much been confirmed for sure. Although as you can see right here, the total amount of dark energy might be a little bit lower than we initially thought. 65%, not 70%. But as I mentioned before, the overall density does not seem to be constant, so it's probably just changing with time. But the dark energy survey is still not done, it's still going to be looking at even more data, and more importantly, we now also have ESA's Euclid mission that we've discussed recently, that's basically going to be sending data and conducting even more observation for many years to come. And we also have the new Vera Rubin Observatory in Chile that's going to be doing even more. And so hopefully in the next 5 to 10 years we'll get even more answers, and potentially an answer that satisfies everyone, explaining everything in the process. No, who am I kidding? I don't think we're going to get more answers. Chances are that in the next 5 years we'll have even more mysteries, more unusual observations, and even more crises for modern cosmology. Mostly because modern theories are definitely incomplete and have way too many holes in them. But it doesn't mean that we should stop observing. As a matter of fact, we should keep observing even more in order to finally discover what is going on out there and where all of this is headed. In the last few decades, the power of telescopes has advanced almost exponentially. We went from being able to see some stars in some frequencies to now pretty much seeing the entire universe in pretty much all frequencies. But more importantly, automation and artificial intelligence now allows astronomers to scan huge parts of the night sky and discover any changes or discover any anomalies pretty much right away. And one of the more intriguing projects that we've discussed previously, that's mostly focused on the Milky Way's bulge and basically our own galaxy, is known as VVV, Vista Variables in the Via Lactea. It's been going on for almost 14 years now, and it's mostly focused on changes in star brightness or something else changing in a star, in order to then help us understand something we've never known about before or potentially discover some hidden mysteries. And intriguingly, we've discussed this particular survey before because in the last few years, it did actually discover a lot of missing stars. There's actually over 1,000 now, but basically these were stars that were visible back in the 50s, in the 60s, and are not visible today. Now you can learn more about this in one of the previous videos in the description, but in a nutshell, it's unclear exactly what happened to those stars and if we've just discovered some kind of a new unusual phenomenon. But discovering a new phenomenon should not really come as a surprise, because these new telescopes have been doing just that for the past few decades. New unusual phenomena, new unusual discoveries, and new unusual stars. And now the scientists have discovered another unusual star we've never known about until now. It does not have a really cool name yet, but their nickname for now is Old Smokers. Ancient stars that turn out to be very unusual compared to anything else. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries from the Triple V survey, find out exactly what these stars probably are, and also discuss some of the other mysteries discovered in these studies. And mostly because a lot of these discoveries can potentially finally explain why some stars seem to have vanished, as you can see from this image, and as you can learn more about in one of the videos in the description. Because the phenomena discovered in this particular study could maybe explain some things. And so here's what we know so far. When it comes to this survey, it's mostly focused on this part. And it essentially tries to focus on specific areas in order to identify long-time changes. And though the main goal for the survey itself is just to find different types of variable stars, mostly because quite a lot of them are usually used in, for example, distance measurements, in this case, these particular studies only wanted to focus on young stars. And here we're talking about really young stars. Stars that are not even stars yet, basically stellar precursors, or sometimes known as YSO, Young Stellar Object. The central objects that will become stars, but are still growing quite dramatically, and usually changing luminosity by huge margins. For example, here is a snapshot of a light curve for a very famous such star known as FU Orionis. You can learn more about this star in one of the videos in the description, but as you can see here, even in a single year it changes quite dramatically, and it's actually difficult to predict how exactly it's going to change or by how much. As a matter of fact, if you look closely, you'll notice that around 1935 it suddenly started to dramatically increase in brightness, but in the last few decades slowly dropped in brightness and is continuing to do so right now as well. Now, because in this case the scientists are basically trying to study these young stars and are trying to understand them a little bit more, discovering even more of these objects out there is of course the main way we can do this. And it's surveys like this that easily allow the scientists to discover them. Here's actually another interesting image of similar objects, in this case taken by the James Webb, and this is in the Orion Nebula. Because Orion Nebula is basically a molecular cloud where a lot of baby stars are forming right now, quite a lot have been discovered by looking at various frequencies of light. But because they don't produce a lot of optical light and a lot of infrared light, usually infrared telescopes are the best to try to find them. But one of the studies here was basically trying to find how these young stars transform into actual stars when basically the fusion starts and the hydrogen starts burning. And here they did actually discover at least 32 such stars. This is just a new discovery, so we don't actually have any details yet, but one of the studies in the description discusses this in a lot more detail. But all in all, approximately 200 different variable stars were discovered by the researchers using this new data. And essentially here we had 200 objects that at some point changed their brightness. Some by just a little bit, some by as much as 300 times. With many of them changing the brightness for just a few months, many of them for a few years. And so most of these were very likely these newborn stars that the researchers nicknamed squalling newborns, or basically newborn stars that had a lot of different emissions and would have a lot of outbursts pretty much every year. But there was some really intriguing additional discoveries that nobody expected. But first, what was expected? Well, apart from these newborn stars, the researchers were also expecting to find typical variable stars, like the one right here, that will usually produce periodic changes in brightness. Naturally, quite a few were found as well. Apart from that, typical variables also include things like nova, very powerful explosions around a white dwarf binary, where the white dwarf basically steals a lot of matter from its partner, with that matter exploding on the surface in the process. And the other interesting phenomenon scientists are interested in is what's known as microlensing, essentially a passage of some kind of a massive object in front of a star that does increase the brightness for some time, but very often only once. So this is not something that's going to repeat again, but something that allows us to study these objects and even determine their mass and their size extremely precisely. But of all of these variable discoveries, 21 did not fit into any of these categories. They were somewhat unusual, yet seemed to be pretty much everywhere. These were very large red giant stars that would dramatically change their brightness for different periods of time. Even more dramatic than Betelgeuse and a lot of other red giants we've discussed recently in one of the videos in the description. And all of them seem to be very old giant stars. Basically stars that are either going to go supernova or potentially transform into something else, such as a planetary nebula, in the future. But surprisingly, most of them seem to be in the same region of the nuclear disk, or basically very close to the central bulge of the galaxy that does contain slightly different molecular composition. And further analysis established that these dips are not because of some kind of a planetary disk or because of some kind of a planet around them. They all seem to last for at least a year, often longer, and because of the way the stars dimmed, it was all very likely due to some kind of a small dust. In other words, just like with Betelgeuse, they seem to have this huge dust cloud that seemed to block the light from our perspective right here on planet Earth. But unlike Betelgeuse, there was no pre-existing large mass of dust, suggesting that this dust was actually being created by the stars through some kind of a process, which is why they were kind of nicknamed old smokers. Old stars producing a lot of smoke. And though at first it was not clear what's happening here, further investigations established that all of these stars were extremely high in metallicity, or basically they contain a lot of non-hydrogen and non-helium elements, even higher than our Sun. And this resulted in a higher production of dust, literally making these stars something we've never seen before. Humongous red stars that basically have smoke coming out of every direction. And that smoke changes their brightness by quite a lot. And so because the center of the Milky Way is quite enriched in a lot of heavy elements, this is probably why these types of stars seem to only exist here. But only 21 so far have been discovered, so we don't really know if this is a common phenomenon. Nevertheless, this presents us with a completely new way. A lot of elements, especially heavy elements, seem to be released into the Milky Way by the stars themselves. Not through supernova or through some kind of a major explosion, just through this unusual smoking process. And that of course means that regions of the galaxy with even more metallicity, or possibly other galaxies that are even richer in metallicity compared to the Milky Way, may have a lot more of these stars, and thus have very different elemental composition, or different types of star evolution compared to what we have here. And so definitely quite an intriguing discovery of a star, or a type of a star, we've never seen before, or never knew existed until now. And I guess even more interestingly, even though the study mostly focused on these young stars, in terms of pure numbers, it actually did find more nova than anything else, and at the same time discovered these unusual old smokers. But because the survey is still going on and there's going to be even more data later on, chances are even more mysteries will be uncovered in the next few years. And once again we have a super exciting discovery of a black hole relatively close to the solar system that absolutely nobody expected. But before we talk about that, let's talk about history, starting with a very intriguing bet between the iconic Stephen Hawking, the iconic theoretical physicist you see right here, and the slightly less well-known but just as iconic Kip Thorne. And so back in 1975, they had a bet. a bet about an object that was really mysterious. It's known as Cygnus X1. An object that you can kind of see right here, an object super bright in X-rays. Here's actually a slightly better image by the Chandra X-ray Observatory. And so Kip Thorne believed that this was maybe a black hole. Yet Stephen Hawking bet against him, but actually hoping to be proven completely incorrect. And in early 90s, he conceded defeat because this turned out to be possibly a black hole after all. And so this turned out to be potentially the first ever black hole to be confirmed. An object discovered back in 1965 by one of these sounding rockets that accidentally discovered an unusually strong X-ray source. Basically one of the strongest X-ray sources in the entire night skies. And because of that initial discovery, and because of the need to study these objects a little bit more, eventually the researchers proposed the first ever space telescope. This was known as Uhuru, launched in 1970 specifically to study these X-ray sources. And it actually discovered at least 300 in the process. And many since then turned out to be possibly either neutron stars or black holes as well. But the reason I wanted to start with Cygnus X1 is because we know so much about it, and because today it's also believed to be kind of extreme. In essence, it's what's known as an X-ray binary. It's a black hole and a relatively large star that sheds some of its mass, which then ends up around the black hole, forming the very powerful accretion disk and extremely powerful jets. And because it produces very specific emissions, over time it became possible to study everything about it. And so today we know that this is approximately 21.2 solar masses and cannot be anything but a black hole produced by a larger star. A star that was probably around 40 solar masses and that approximately 5 million years ago possibly collapsed into the black hole without actually going supernova. And the reason we believe it did not go supernova is because it seems to be in the same location. Normally during supernova, black holes shift because none of the supernova turn out to be perfect. They usually give black holes just a bit of a kick. And so in essence this was the birth of X-ray astronomy and the first ever black hole to be discovered and confirmed. And here the distance between these two objects is approximately 0.2 AU, or about 20% the distance of Earth from the Sun. But it's always believed to be an extremely rare example of these X-ray binaries because the black hole here seemed to be a little bit too massive. In most cases, solar mass black holes are expected to be just a little bit less massive, possibly around 10 solar masses or even less. And so 21.2 solar masses was already kind of pushing it. It was essentially so bright because the black hole was just so massive. But on the other side of the equation, there were other propositions of even more massive black holes that we just are not seeing because they're not emitting any energy, or because their partners are just too far away and so no accretion disk is formed and the black hole remains kind of quiet. And while to everyone's surprise, there's a new unusual discovery coming directly out of data from the Gaia telescope. The telescope that's actually really good at measuring speeds of different objects across the galaxy, the idea known as astrometry. And so here, by focusing on various stars in the galaxy that seem to have deviations from their motion, usually involving some kind of an orbital change, the researchers discovered something really strange right here. This is a relatively large, relatively bright star located not so far from the Sun, roughly around 2,000 light years away from us. And it's also in the galactic halo. And what's really intriguing about this star, as you probably guessed by now, is that it seems to orbit a relatively massive black hole. A black hole that potentially is approximately 33 solar masses at least. But because the star here takes approximately 11.6 years to orbit the black hole, it's not really close, and it's not shedding any mass, not creating an accretion disk, and the black hole remains quiet. But based on the analysis, it seems to be really massive. As you can see right here, more massive than Cygnus X1, and way more massive than the closest black hole to us, also discovered by Gaia, Gaia BH1. And I guess once again, what's really surprising here is the distance. This is one of the closest such black holes to us. Gaia BH1 is 1500 light years away, this is only 2000 light years away. In contrast, Cygnus X1 is 7000 light years away, and once again, the only reason we've known about it is because it's so ridiculously bright and so ridiculously powerful. Yet this black hole, in theory, could produce something even more extreme, yet it stays quiet. And the only way it was discovered is by just seeing these minute deviations in orbit of the star that you see right here. But naturally, because this is a scientific study, we also have some additional discoveries in regards to all of this including the location and why it matters. And so first, by using additional observations, including ultraviolet observations, and by using various large telescopes such as VLT, researchers were able to discover what sort of a star this is in order to figure out how this black hole became so large. And that's because generally we know that when you have a binary system, it's kind of assumed that these two objects very likely formed at the same time from the same stuff. And so by knowing what the star is made out of and what sort of a star it is, we can then make conclusions about the black hole. And so a thorough analysis of the star revealed that it seems to be metal poor, or in other words, mostly contains hydrogen and helium, and is not particularly developed elementally. And based on observations of other metal poor stars, we know that they generally don't actually lose as much mass as much more developed stars when it comes to stellar emissions. And so when they actually reach the point where they're about to go supernova or form into a black hole, they will actually have a much higher initial mass compared to a much more developed star. And so in essence, the discovery of this binary system provides evidence for a hypothesis that links metal poor stars to extremely high mass black holes that seem to form without supernova through direct collapse. Here's one, and there are probably a bunch more still hiding that we're going to be discovering in the next few years. And mostly because Gaia is just so good at finding these wide binaries, or essentially binaries where something is orbiting something else, but something that can only become visible once the motion of the star is revealed to be somewhat unusual, which is exactly what happened here. The motion of the star did not make sense unless it was orbiting something massive with a somewhat eccentric motion. And because this particular study was so good at finding this, it's quite likely that in the next couple of years, more and more data will be analyzed in a very similar way, revealing so many more of these hidden black holes all over the place. Once again, this one was actually really close to us. It was always there, we just never saw it. And once again, it does not seem to be in the galactic plane. It seems to belong to a different structure, such as possibly a stellar stream, like the one known as ED2. One of many stellar streams that exist around the Milky Way that essentially represent various leftovers from various collisions with other galaxies in the last few billions of years. And so in this case, this particular black hole and this binary system potentially belongs to a different ancient galaxy, although since the black hole formed 5 million years ago, it was already part of the Milky Way when all of this happened. But exactly how all of this connects to the evolution of the Milky Way, and exactly what this shows us about how things in the galaxy evolved, is not something we can answer yet. Most of the recent discoveries of various streams are also a result of studies based on Gaia telescope, and so it will probably take a few years, and maybe like a decade, to finally figure out what all of this means and how all of this played out over billions of years. But at least for now, this is just a super exciting discovery. A discovery of an extremely unusual black hole very close to us that was always there, but nobody saw until now. When I'm making this video, it's now been just over a week since the legendary 2024 total solar eclipse, one of the most fascinating astronomical events of the last few years. And so I figured it would be a perfect time to do a kind of a general debrief, focusing on some of the most unusual discoveries so far, and also some of the more unusual images captured from various perspectives. And although we've discussed a lot of this during the stream on April 8th, the link for which you can find in the description below, today I wanted to focus on some of the things most people basically missed or might have been not aware of. And also talk about some of the first discoveries that were made during the eclipse. And I think the biggest one is actually right here. A discovery of a comet, SOHO 5008. A comet that was discovered by several amateur astronomers and actually picked up by the NASA's solar observatory known as SOHO, which is why it's called SOHO 5008. And the number here might also be a bit of a hint. This is the 5008th comet discovered by SOHO, and pretty much all of them were extremely close to the Sun. These are known as the sun grazer comets, and most of these comets only get discovered really close to the Sun and actually only survive for a few hours. And this comet was no exception. It was essentially discovered, observed, and then disappeared, all within approximately 12 to 20 hours. Mostly because these comets pass extremely close to the Sun, usually just a few million kilometers away from the surface, or at least 10 times closer than Mercury to the Sun. And these comets are surprisingly very common. And they're often discovered during eclipses because it's usually the only way for us to physically see what's hiding near the sun without being blinded by its extreme luminosity. But officially some of the first sun grazers were discovered back in 1882 by a group of early astronomers observing the eclipse in Egypt. And during this time, a German astronomer, Heinrich Kreutz, was actually able to discover that a lot of them seem to have an extremely similar orbit, as if they came from the same object. And so today we refer to them as Kreutz sun grazers, and many of them are believed to be tiny fragments of a much larger comet that was possibly observed by Aristotle back in 371 BCE. And that comet basically broke apart, creating smaller pieces that are now orbiting in a very eccentric orbit that you sort of see right here. And once in a while, one of them approaches really close to the sun, gets smaller or even gets destroyed, and if it survives, it disappears again for a few thousand years. And so SOHO has been discovering a lot of these with pretty much very similar orbits, sort of confirming this hypothesis that they all came from the same body, with this piece being the most recent. But one of the most impressive pieces was seen in 1965. This was comet Ikeya-Seki, that was actually one of the brightest comets of the 20th century. And so chances for another one are actually pretty high. Because there are so many fragments that are still in orbit, here it's just a matter of waiting for a large enough piece to approach the sun. But intriguingly, the comet that everyone was waiting for, 12P or Pons-Brooks, visible in this beautiful image by Jan-Erik Velestad, was nowhere to be seen. For some reason, it was not actually that easily visible, and so I couldn't actually find any incredible images of this, because I guess most researchers focused on a newly found comet, SOHO 5008. But this comet is actually really interesting because it's sometimes known as the Devil Comet, and is technically a cryovolcano. But I guess because it was kind of far away from the sun, the only way to take a photo of it would be by using some kind of a wide field lens. And so anyway, no super cool pictures, at least for now. But we have some really cool shots from outer space. Here's a time lapse showing us the passage of the shadow moving at over 2,000 km per hour, captured by the National Oceanic and Atmospheric Administration satellites that are usually responsible for studying things like hurricanes. And here's an even more awesome shot from ESA. And this is, to me at least, absolutely mind-blowing. You can actually see this huge, creeping darkness approaching North America just before it swallows everything and then disappears. And so yeah, no wonder the Mayans and the other ancient civilizations were so terrified of this. It does look kinda scary. And in this case, this was captured by a geostationary satellite, GOES-16, from approximately 36,000 kilometers away. But this wasn't just to make a cool video, this was actually scientific as well. Here, this is an ongoing study that doesn't actually have any publications yet, in regards to environmental changes during the eclipses, focusing on temperature changes, cloud cover changes, and various pressure changes in the upper atmosphere. We still don't really have details on what's up here, but these studies are going to be coming out really soon. And so make sure to subscribe, because we'll talk more about this very soon. Then we had more shots from other satellites such as Discover or Deep Space Climate Observatory, but I guess this one is maybe not as impressive. But then we also had a few shots from the International Space Station. Here's a picture. This was captured by the NASA's camera on the ISS. Here's another shot capturing Quebec and New Brunswick in Canada, with a part of the resupply spacecraft visible here as well. Here's a slightly different angle where you pretty much see the entire shadow. But here is something that was actually taken, I guess, by accident. This is a shot from one of the Starlink satellites by SpaceX that was able to capture the footage of the moon's shadow as it was orbiting Earth. And this actually looks absolutely awesome as well. Although what's intriguing in this particular video is that it seems to be wobbling a little bit. There's a bit of a shaking going on, which I'm guessing is a result of the motion of the solar panels making the video vibrate just a little bit. Or maybe something here is broken and they need to take a look at this. Either way, an amazing shot and something that we've never seen before. But interestingly, that shot from the International Space Station was technically planned. NASA has been gradually moving the International Space Station so that it would actually pass through the solar eclipse, experiencing approximately 90% totality, but also changing the orbit in order to avoid certain space junk. We'll talk more about this in some of the future videos. Either way though, there have definitely been so many gorgeous shots. And quite a lot of them came from various NASA scientists, like the one that you see right here. By the way, all of the links and all of the credits are also in the description below. But here's actually a really cool video of the NASA pilot collecting the data while flying through the eclipse at a ridiculously high altitude at nearly 60,000 feet, flying on one of the NASA's scientific airplanes known as WB-57. high-altitude research aircraft. And here the mission was to study the upper atmosphere once again. No actual results yet, but the data has been collected, so it's just a matter of time. And then there were obviously quite a lot of different images and pictures from the ground as well. Here's one showing us a very common phenomenon known as solar prominence. Huge loops of plasma that are actually several times larger than planet Earth, produced by various magnetic effects on the Sun. Now, some people were actually able to see this during the totality as well, but in most cases you had to have some kind of a telescopic lens. This one was captured by one of the NASA scientists, Barber, and there were quite a lot of shots of these prominences from different angles. But they weren't really as large as before in some of the previous eclipses, because for some reason, to everyone's surprise, even though this is basically the peak of solar activity, on that day, the Sun decided to be somewhat quiet and produce almost no emissions at all. And so the prominences are basically kind of small. Here's actually another cool shot by the same photographer, and here you can even see the magnetic lines extending inside the corona, producing these very beautiful streaks. But in most cases, almost everyone saw another really cool phenomenon, the Baily's beads. The unusual streaks usually visible on the Moon, which are actually a result of lunar landscape and specifically mountains and ridges, as they let some of the light from the Sun through, forming these unusual speckles. And this is very often mistaken for different solar emissions or even solar flares. But this is a completely different phenomenon. You can actually learn more about this in one of the previous videos in the description. Here's another cool shot from Texas by the same photographer. And then we had the launch of 3 sounding rockets, one of which you see right here, that essentially went into the upper atmosphere and then into the ionosphere in order to study the effects solar eclipses usually have on the ionosphere or even the magnetosphere of the planet. In this case, the data has also been collected, just not processed yet, and so we don't really have any conclusions, but we know that the mission was a success. All of these 3 rockets launched half an hour apart, returned, and collected enough data. But then we also had some unusual reports pretty much a day or two after the eclipse. Turns out that hours and days after the eclipse, there were millions and millions of internet searches on Google looking for the term "my eyes hurt." So yeah, I guess people didn't really listen to advice and looked directly at the Sun after all, even though so many of us have been continuously warning everyone not to do it. I mean, technically you can look at the Sun for maybe 4 minutes during the totality, but even that is a bit risky. And so here they've probably all gotten what's known as solar retinopathy, essentially damage to retina as a result of exposure to extreme brightness. And the thing is, normally there's no pain, mostly because that part of the eye does not have any nerve fibers. But the eyes afterwards do get inflamed, and that's where minor pain may start. Luckily though, this is not a permanent problem and can technically disappear after a few weeks, maybe a few months. Although in some cases it can be permanent. So yeah, don't look at the Sun, unless you are a telescope specifically designed for this. Such as this beautiful telescope you see right here, known as Daniel Inouye Solar Telescope, located in Hawaii. And it too was able to take an incredible shot of the Sun. Now this is something I've never seen before, and this looks absolutely incredible. But this does have a purpose. This is actually really important for the telescope. Here the data was acquired in order to calibrate optical systems and instruments in the telescope itself. Because the telescope here has to usually correct for the very turbulent atmosphere of planet Earth, and it usually employs what's known as adaptive optics, this was a perfect opportunity to calibrate the optics by using this beautiful shadow and of course the Sun itself. And what's really awesome about this shot is, well, you even get to see tiny mountains on the Moon. As you can see, this is not a perfectly straight line, and it shows us the rugged surface of the Moon. This is really awesome. Probably one of the best shots I've seen of the Moon during the eclipse. But obviously, apart from looking at the Moon and looking at the Sun, some people observing the eclipse also realized something around them started changing as well. As we've discussed previously, during the eclipse, usually the air becomes much colder, even dropping by up to 10 degrees, and the winds as well as clouds can completely disappear. And this is apparently something that a lot of my friends in Canada witnessed as well. As soon as the eclipse started, they all had to put on jackets and it became really cold. But one of the strangest effects we observed during the eclipse is what's known as the Purkinje effect. It's essentially how we perceive colors, and specifically the vibrance of colors, in different light conditions. And so a lot of colors that are usually vibrant in daytime become extremely dark and barely visible. And vice versa, some colors that are normally not very easily visible become extremely bright, transforming everything around us. Now it's actually a little bit difficult to explain this without really seeing it, but this is a very well-known effect, and we'll probably discuss this in some of the future videos, because the actual explanation is a little bit more complex, and there's a lot of physiology behind it. But it wasn't just colors people were looking at, a lot of people were also trying to look at animals, mostly for different scientific studies that were being conducted during this time. And that's because different teams, including the team from NASA, wanted to actually figure out how various animals react to solar eclipses and what effects these particular events might have on different types of life. And once again, we had some really unusual results from various zoos around the planet. Now this is very preliminary, and I'm sure there will be more that we'll talk about later, but for example, in one of the zoos in Texas, quite a lot of different animals, gorillas, tortoises, elephants, bonobos, mistook eclipse for nighttime and basically went inside their enclosure getting ready to sleep. And strangely enough, this behavior was different from what was observed from similar animals during previous eclipses, such as the one in 2017. And this also applied to most of the birds in the zoo, but not all birds and not all animals. Flamingos, as well as zebras, giraffes and chimps, suddenly changed their behavior, either running around or patrolling around, or even coming together for safety, as if they were super stressed and had a lot of anxiety. Whereas other birds, such as waterfowl, suddenly quieted down for at least 4 minutes, and as soon as the eclipse was finished, one of them suddenly started making loud noises, with a lot of birds then joining in, as if it was suddenly morning. There was even at least one ostrich that for some reason laid an egg, right in the middle of the eclipse. Nobody knows why, but it did seem to happen. And so quite a lot of observations from several zoos, such as the one in Vermont and one in Quebec, reported on a lot of unusual behavior in various species. Then there was some really strange behavior in Japanese macaques. For some reason, all of them completely stopped their interaction, turned their backs to the sun, and just stayed calm, sitting down, doing nothing for 5 minutes, returning back to their normal routine as soon as the eclipse was finished. And this is not at all what the researchers expected them to do. For example, previously, in other macaques or even baboons, the most common behavior was pointing, screaming, and basically being anxious. So yeah, these macaques were possibly not impressed. But basically most animals, even goats, had some kind of a reaction. In case of goats, for example, they all started moving around and shuffling for approximately 5 minutes as well, but then stopped and returned to their normal routine as soon as the eclipse was finished, with some animals basically doing the opposite of what they usually do during daytime. For example, cranes, which are normally very vocal, were completely quiet for 5 minutes, with the only animal that didn't seem to care at all once again being a bear. None of the bears did anything different, and they all just basically did whatever they were doing before. And this is something that was observed in every single case for many years. Bears don't seem to do eclipses. But what about the most complex animal of them all? Us. Well, I'm sure there will be more studies coming out about all of this in the next few months, but one of the first unusual discoveries was really surprising. There was an enormous drop of internet use during this time. Nationwide, it was by about 8% in total, but in places like Vermont that experienced one of the coolest eclipses ever, it was by up to 60%, which basically suggested that humans stopped what they were doing and went outside to look at the eclipse for at least 5 minutes, but in most cases actually up to an hour, making this one of the most important events of the last few years, and for quite a lot of people, quite a transcendental experience that they're going to remember for their whole life. And so yeah, super cool event, with the next one in 2026 being in Spain, Iceland and Greenland. So maybe I'll be there, hopefully, I don't know. Well, as you probably know, last week, sometime around May 10th, our planet has experienced one of the biggest series of geomagnetic storms of the last 2 decades. The storms that you can kind of see right here, visualized by Space Weather Prediction Center. And as it usually happens with such storms, following the storm, once this actually got to planet Earth, we got to experience some of the most impressive aurora ever seen. Visible as far south as Hawaii in the northern hemisphere, or as far north as Queensland in the southern hemisphere, with lots and lots of beautiful images circulating the web, basically showcasing this incredible phenomenon. And though obviously seeing aurora is not unusual, seeing them so far north or south, depending on the hemisphere, is of course very strange. Which basically highlights how absolutely ridiculous this particular emission was. And so, hello wonderful person, this is Anton. Let's discuss this event in a little bit more, I guess, scientific sense, talk about what this means and how these aurora work in general, but also briefly discuss how this was potentially predicted in a very important paper back in 2019. But I guess first, let me show you this image to basically highlight how this time we might have once again got super lucky. So as always, this type of an event basically began in the middle of a sunspot. And in this case, this is a sunspot referred to as AR3664. A superactive sunspot that just recently, when I'm making this video, has actually done another emission, but this time going away from planet Earth. Here's an actual image of this sunspot taken by one of the satellites by NOAA. With NOAA recently observing one of the most powerful solar flares seen in the last few decades, all coming from this sunspot, and all within just a few days after these super powerful emissions headed to planet Earth. And what's even more surprising is that NOAA also made an extremely rare announcement about this sunspot and of course about the emissions that happened around May 10th. The announcement being that this was going to result in an extremely powerful geomagnetic storm. Powerful enough to potentially damage a lot of technology on the planet, and essentially that type of a geomagnetic storm that we always kind of dreaded. The, I guess, so-called Carrington-like event. And so yeah, back to that picture I was going to show you. Turns out the sunspot was actually not that different from the one that caused the Carrington event. Very similar both in strength and in size, and basically releasing a huge amount of stuff when it was facing planet Earth. Here, as you can see from this simulation, this was actually a series of 5 coronal mass ejections and also multiple solar flares, all of which hit planet Earth. And so yeah, technically this was our Carrington event to some extent. Here this was classified as G5 storm, the highest possible geomagnetic storm we can experience. And here it actually happened twice during that weekend. Here's a slightly different view showing us these coronal mass ejections happening one after another. And by the way, Carrington event was also a G5 event. But comparing this to a Carrington event might not be as accurate because we don't have enough data about that event, but interestingly we actually experienced something somewhat similar in 2003 as well. This is often referred to as the 2003 Halloween solar storms that also resulted in huge aurora, but also major damage and power outages in countries like Sweden and South Africa. Actually, South Africa experienced a tremendous damage to its power infrastructure because a lot of power transformers basically exploded. And so here, something similar was feared as well. But luckily for us, nothing seems to have happened. For example, during such storms, we sometimes expect major problems with satellites or even satellites falling out of the sky, because during this time the atmosphere of the planet expands just a little bit, enough to dramatically influence orbits of certain satellites. For example, the ones SpaceX is launching, and they've already lost a few satellites to previous solar storms, but this time nothing happened. No damage to satellites, no major damage to any power grids, although some unusual irregularities have been observed in the US, and only temporary disruptions to systems like GPS. But everything else seemed to be fine. And it's unclear if this was just because we got super lucky, or maybe we just became a little bit more prepared after initial disruptions in 2003 and before that. Nevertheless, just the fact that this was an extremely similar sunspot to the Carrington sunspot, with the overall emission of coronal mass ejections being somewhat similar as well, is of course kind of surprising. And in case it's not clear how big this thing is, this is actually approximately 15 times bigger than planet Earth. So yeah, this is not a small sunspot. And it was really surprising that NOAA decided to call this a historic event, because despite not actually observing any damage on the planet, the damage could have been done and it could have been catastrophic. So at the moment I'm kind of curious to read some studies or papers about why nothing seems to have been damaged. I mean, did we actually get super lucky, or are we kind of prepared for more such events in the future? But the reason I wanted to start with this and why this is so powerful and so important is technically because it was predicted by a study a lot of scientists kind of ignored early on. And it has something to do with trying to explain solar cycles. Now you might know that solar cycles are technically 11 years long. So basically every 11 years our sun goes through the peak and then comes down, reverses its polarity and starts again. You can check out some of the previous videos that talk about each of these individual stages in a little bit more detail. And we basically are now in our cycle 25, and a lot of previous studies, actually even based on this graph, assumed that this cycle is going to be one of the weakest, but not the study from 2019. And that video from 2019 with the much younger and I guess less jaded and slightly happier Anton talks about this in more detail, because here the prediction was that this is going to be a huge cycle and we're going to have some major emissions and very likely a Carrington-like event that could happen anytime. And they even predicted this to happen maybe around 2024-2025. So yeah, a prophecy. Well, not really. They did some really good science there, and the calculations were pretty accurate. And so it turns out that they might have been correct, with the explanation here being that the solar cycle is not 11 years long, but is technically 22 years long. And because we observed a major emission in 2003, we should also maybe expect one around this time as well. And, well, it happened, and this is definitely one of the strongest cycles we've had for a very long time. But here's the thing. It's not technically over yet. Technically, the peak is going to be next year in 2025, and so this might happen again in the next year. Although when it comes to this particular sunspot, it has now turned away from us and is unlikely to bother us anytime again. But yeah, in some sense, we basically just lived through a kind of a Carrington-like event that resulted in some of the most impressive light shows on the entire planet. And though they actually resemble most aurora, what's surprising here is of course the location. A lot of these were in places that have not seen aurora for nearly 100 years, which basically highlights how ridiculously powerful these events were. But before I finish this video, I also wanted to briefly explain what exactly we're looking at when we're seeing aurora and how all of this works. Because here, by observing the interaction of coronal mass ejections with planet Earth, we can then basically tell if this was a powerful event or if this was something a little bit more mild. In a nutshell though, this is obviously the result of magnetosphere interacting with the solar emissions, and it sort of works like this. You have these very powerful ionized particles approaching the planet, and as they basically push on the magnetosphere of planet Earth, a lot of these charged particles end up depositing in different regions around the planet, and as they follow the magnetic lines, they start colliding with the upper atmosphere at very, very high velocities. And because of these powerful collisions, various gases in the upper atmosphere start to become ionized, or they essentially reach a slightly more energized state where they're not particularly stable. And the two biggest particles that are responsible for most of the colors are nitrogen and oxygen. And here's what we usually observe when oxygen becomes ionized in the upper atmosphere. When these charged particles strike molecules of oxygen, it becomes ions of oxygen. And these ions can generally do one of two things. If they're ionized in the lower atmosphere, or basically where we are, they usually combine with something else, then becoming some kind of a different element, or sometimes becoming ozone. However, if this happens in the upper atmosphere, where the density and the pressure is extremely low, if they stay in this state for at least 1 second, they then release this extra energy as light and return back to their unexcited state. This is actually one of those things explained in quantum physics, and here they basically go from something called S state to D state. But they can only do this if nothing else disturbs them and if there are no additional atoms around them, for at least at 1 second. And the photon that they release turns out to be green light, which is exactly what you're observing here. All of this green light is formed by this upper atmosphere oxygen as it's energized and then releases extra energy as photons. But when you have an extremely powerful emission, such as the one we've just observed, that releases way more high-energy particles than ever before, they start ionizing oxygen even higher up, where there are even less particles and even stranger interactions. Here, if ionized oxygen does not get disturbed for at least 1 minute, it can then actually transition to another state known as P state, emitting red light. And so during some of the most powerful coronal mass ejections, we also get to observe these very beautiful red aurora extremely high in the sky. But that was just oxygen. Nitrogen does something very similar, but produces different colors. And it can actually emit either blue light or red light, but will usually produce a combination of both, resulting in something that resembles this. Basically something that's more magenta in color. And so the combination of these colors can normally tell us a little bit more about the power of the event, which in this case, since all of these colors were observed, reminds us about the power of this event. The event that doesn't have a name just yet, but I'm sure someone is going to come up with some really cool name for it in the future. Actually, if you do have a cool proposition, leave it in the comments below. The funnier and the cheesier, the better. And so, I guess in conclusion, in terms of scientific value, this was a super important event. but it's also an event that surprisingly managed to not damage anything, despite its ridiculous power and despite all of the effects produced in the upper atmosphere. And it's also an event that reminds us that we still don't really understand everything about the Sun just yet, and that the cycles might be a lot more mysterious than we ever thought. And most importantly, since this is still not finished, we still have at least a year to go, and so yeah, get your cameras ready, but also maybe stock up on like some extra food and water and stuff, in case electricity goes out. Although hopefully next time, NOAA, and I guess other government agencies, will give us a little bit more heads up, possibly a few days in advance. This time they basically announced it, and the next day it was already here. But yeah, once again, in terms of sheer power, as you see from this simulation, this was kind of ridiculous. And the fact that most of us didn't even notice is also kind of hard to believe. Hello wonderful person, this is Anton, and today we're going to discuss a somewhat important discovery in regards to, I guess, everything in the universe. The universe seems to be vibrating. As you might have discovered from one of the older videos that should be in the description and that we've discussed in 2023. And specifically this is the observations of gravitational waves. But not really the same types of waves as we usually observe when two smaller black holes collide, creating a kind of a chirp. Here we're talking about a very different type of a wave that seems to be more or less constant and seems to have existed, well, possibly forever. And so in this video, let's actually discuss some of these new discoveries and new confirmations about this, possibly talk about what's causing this and also what's very likely not causing this, and I guess what all of this means for us as humans. And by the way, what you're looking at right here is a simulation of a pulsar or a neutron star whose existence was crucial in discovering all of this. We'll talk about this in a few minutes. But I guess first, just a little bit of history. Everything we know about gravitational waves technically changed in 2015, mostly because we finally had a physical confirmation that gravitational waves exist and are definitely produced by colliding objects such as neutron stars and black holes. But this only happened in 2015. Some of the older videos on the channel, somewhere right there, explore this a little bit more. But the idea of gravitational waves does not limit itself to collision of smaller black holes and neutron stars. Gravitational waves exist everywhere and at all times. Or at least that's the theory behind this. And so back in the 70s, some of the theoretical physicists started to propose various ideas on how we can detect gravitational waves by using the idea of interferometry, which could be done by observing tiny changes of some kind of a measurement by looking at various objects at a distance. Eventually this of course led to various facilities like LIGO, which then detected gravitational waves and proved their existence. But initially this was not about neutron stars and black holes, this was about a much larger gravitational wave, sometimes referred to as the background gravitational wave. A much larger wave and potentially much higher in amplitude, generated through the interaction of massive objects such as supermassive black holes, possibly dark matter, and possibly more exotic objects such as cosmic strings. Something you can learn more about in some of the videos in the description. But the question is, how would you actually look for these large waves and how would you prove their existence? And well, back in the 60s, the researchers discovered something else that could technically help us with all of this. Pulsars, and specifically millisecond pulsars. Pulsars that spin hundreds and even thousands of times per second, with the average period being about 10 milliseconds or even less. And so by taking a few of these millisecond pulsars, located everywhere in the Milky Way with very specific rotation periods, we can then basically measure minute deviation in their extremely precise rotations. Millisecond pulsars are known to be very stable. They don't generally have starquakes or glitches, and are technically even more accurate time predictors than atomic clocks. Fun fact, the famous golden disk on the Voyager 1 and Voyager 2 features what's known as the pulsar map, basically showing the location of the solar system by using several famous pulsars that were known back in the 70s. And so in essence, by using this principle, or by basically using this pulsar map, it then becomes possible to measure minute deviations of space-time that could potentially happen because of gravitational waves. Okay, this might sound super complicated. I guess let's use a more earthly example. Let's take a boat or a ship. So imagine some kind of a boat on the ocean, and here you basically are trying to find out if there are any, tsunami waves coming toward you. Now normally, if you're in the ocean, you're not going to feel tsunami as it passes over you, because the wavelength of a typical tsunami is in hundreds of kilometers. But you might be able to detect it if you look at different distant objects, such as different lighthouses, and by constantly observing them, manage to find slight deviations as the tsunami passes over you. Now this is a gross simplification, but in essence that's the idea that's used here. The boat is planet Earth, these lighthouses are pulsars, and the tsunami wave is that background gravitational wave that the scientists are trying to discover. And though this might sound really complicated, the initial discoveries of something going on here were actually made in 2016. And this was achieved by using the first such survey, or the first such technique, known as the Pulsar Timing Array, PTA. But this was obviously very preliminary. Nevertheless, this actually started a major research in the last decade. More and more teams started to join and started to conduct their own observations. And as of 2024, we have at least 6 separate surveys. The first one was the Parkes Pulsar Timing Array, which began collecting data in 2005. Then we have the European Pulsar Timing Array, the North American Nanograph, the Indian and the Chinese Pulsar Arrays, and lastly the South African Meerkat. And these basically include some of the biggest radio telescopes in existence, with many of these observations being extremely accurate. But all essentially focused on one thing: measuring the timing of various pulsars, millisecond pulsars, and basically trying to calculate minute deviations from the known period. Here it's normally measured in nanoseconds, but the biggest breakthrough was in 2023. That video in the description talks about this more, but essentially the combination of the North American and the European pulsar arrays combined approximately 15 years of observations, discovering very strong evidence for the existence of this unusual background gravitational wave. Although technically it's not a single wave, it's more of a superimposed gravity wave that's very likely formed by different events combined into one. Not so different from what we usually observe on the surface of a typical ocean. And naturally, this discovery presented us with a very important opportunity. Just like the cosmic microwave background radiation, here we had the opportunity to study the universe by discovering some of the earliest waves coming from anywhere. Since gravitational waves pass through everything without really interacting with anything, these waves could have been generated right after the Big Bang, naturally making this a super important study. But because this is so groundbreaking and because it potentially has so many implications, naturally we need more confirmations and more evidence. And that's exactly what we got now. A second release by the European Pulsar Timing Array, using the second most recent dataset, that was actually joined by the Indian Pulsar Timing Array that provided very similar results. All of this released in May of 2024, or basically a year after that last release. And all of these individual observations are pointing at the same result. Every one of these pulsar observations suggests the existence of long wavelength gravitational waves produced by some kind of a mysterious signal. In this case, this is actually based on 4 different datasets, with the evidence being overwhelming. And so this definitely proves the existence of these waves pretty much all around us at all times, even right now. But naturally we don't really feel them, mostly because it's gravitational waves, so you're not going to feel it either way, but also because they're not really that large in amplitude. They might obviously shift our atoms here and there, but not by much. But one question that has been so far difficult to answer is, okay, but what's actually causing this? Based on previous studies, the assumptions here have been quite diverse. For example, one assumption was the mysterious cosmic strings, extremely massive cracks in the space-time itself, that have been proposed to exist and could potentially cause these waves. Or maybe orbital interactions between supermassive black hole binaries in various galaxies as they collide and as they're about to merge. Or maybe all of this was the result of the mysterious inflation that happened right after the Big Bang. Or some other unusual phase shift in the early universe that transformed the universe from something else into what it is today. Or maybe, as always, the mysterious dark matter. In this case, what's known as the ultra-light dark matter, such as maybe some kind of an axion or neutrino. Here, by having a lot of them and oscillating in a certain way, they would also produce gravitational waves. And though at the moment it's still kind of difficult to pinpoint the exact source, here by combining data from all of these pulsar timing arrays, the researchers were able to kind of come to one potential conclusion while also discarding a few other ones. And so here the data suggests that it's very likely not dark matter. or at least not ultra-light dark matter, as predicted by some of the studies. It's also unlikely to be different types of exotic stuff like cosmic strings, because the overall wavelength and the amplitude doesn't seem to match, but it does match supermassive black holes. And so right now the scientists believe that the signal here is almost certainly caused by in-spiraling supermassive black holes in various interacting and colliding galaxies, such as the famous antenna galaxies that are slowly merging and whose black holes eventually will probably have to merge as well. And because here the amplitude is a little bit higher than expected, right now massive black holes seem to be the best explanation. And so here, by observing 68 pulsars for approximately 15 years, we essentially have an almost direct confirmation for the existence of a bunch of supermassive black hole binaries all around us. And the binaries that are most likely going to combine at some point. But because here we're talking about waves with wavelengths in thousands of light years, these events are going to last for millions and even billions of years, and so none of these black holes are going to be combining anytime soon. But all of this connects to one important mystery known as the final parsec problem. One of the videos in the description talks about this a little bit more, but this basically confirms that supermassive black holes definitely interact and definitely reach a point where they start producing gravitational waves. But whether they actually combine at the end is not a question we can answer yet. I mean, technically they have to, we just don't have enough evidence. But obviously, because this is such a groundbreaking discovery, this is not the end yet. We're going to be getting even more observations by 2025, with all 6 pulsar timing array observatories very likely releasing even more data in the next year. And so by combining measurements from all of these collaborations, we might be able to pinpoint the exact source a little bit better. At the moment, it's still kind of a guesswork, we just know these waves definitely exist, and the evidence so far is extremely strong, but the explanations right now are very preliminary. And so once we know a little bit more, or once someone discovers exactly what's happening here, we'll come back and talk more about this in some of the future videos. If you've been following astronomy long enough, you're most likely familiar with the idea of dark matter, a proposition for some kind of an invisible particle that seems to introduce approximately 5 times more mass into the universe compared to what we physically see with our telescopes. And so, for example, even though in a typical galaxy like the Milky Way, we might see a certain number of stars and certain amount of gas, when we look at orbits of these stars, it becomes apparent pretty quickly that there seems to be a lot more hidden mass that we don't observe because these stars are moving way too fast. And that's actually true for pretty much every single galaxy we've seen so far, and that's basically how this idea of dark matter was born. Although technically it was actually Fritz Zwicky that originally proposed this idea back in the 1930s for a slightly different reason. He was actually looking at a galactic cluster known as the Coma cluster, and here he measured the orbital velocities of galaxies around the central point and around one another, realizing that here there seems to be way more mass once again hidden, because otherwise these galaxies would basically fly apart. And so when he saw this, he basically said, well, maybe it's some kind of a dark matter. Okay, I wasn't there, so I don't really know what he said, but that's the story. And so for many decades now, researchers were speculating that at some point we're going to find this unusual dark matter particle, the particle responsible for producing all of this extra mass. But despite decades of research, and despite a lot of really complex dark matter detectors, so far nothing has been officially confirmed. There have been signs here and there, but nothing concrete yet. And as a result, a few decades back in the 80s, an Israeli researcher, Mordechai Milgram, who you see right here, made a slightly different proposition. He basically changed the Newton's law of gravity just a little bit, suggesting that maybe at faraway distances, or to be more specific, at low accelerations, the law of gravity changes and has additional components that could definitely explain what we're observing in, for example, rotating galaxies. And turns out that his prediction was relatively good. He was able to explain why galaxies spin the way they spin, and was even able to explain a few more things. And though it could not explain everything, including for example the observations from the Coma cluster, here it was essentially assumed that this is just a matter of time before someone finds a way to explain all of this using this new proposition. It became known as MOND, Modified Newtonian Dynamics. And so, hello wonderful person, this is Anton, and today we're going to discuss basically, I guess, the death of MOND, because it might have been officially killed once and for all. Several major studies, including studies by previous MOND researchers, have now officially showed that there seems to be no MOND effect anywhere after all, at least based on some of the predictions that were made in this unusual proposition, with recent data from extremely accurate observations basically showing us that all of the results seem to be purely Newtonian and not modified Newtonian. And so I guess let's discuss some of these studies and what they've discovered, and to some extent talk about, I guess, the future of dark matter research. First though, as always, you can find all of the articles in the description below, with this one by Indriana Urbanik and Harry Desmond basically being the one that summarizes everything. And so one thing about MOND that was kind of interesting is that it essentially predicted additional effects at low acceleration that technically could be detected by looking at individual objects in the solar system at faraway distances, or even things like binary stars. Specifically wide separation binary stars, where the distance between two stars is so large that their overall acceleration is really tiny. And so on the outskirts of a typical galaxy, or on the outskirts of a typical star system, we might actually see MOND effects and even be able to measure them, allowing us to either confirm or disprove this idea. And interestingly, in the last decade or so, there actually have been several papers that to some extent potentially found evidence for this MOND proposition. And so after years of looking into this MOND model, I basically became intrigued because, well, for one, we couldn't really find any dark matter particles yet, and I guess two, a lot of researchers seem to support this idea, even though obviously not all researchers. But this being science, it's cool to have an idea or a proposition, but you have to have evidence, and you also have to have a lot of studies, preferably from some kind of a multi-angle approach. And unfortunately, when it came to MOND, most of the studies usually just focused on one of two things. Either galactic rotation curves, or in some cases, very specific galactic interactions that were only predicted by MOND, but not a lot of other theories. And so it really kind of looked more like a confirmation bias, more so than anything else. Here we needed to have studies that try to disprove one of these predictions by using the data collected over the years. And in a video a few months ago, we've discussed the first such study. It was actually quite groundbreaking, but it basically focused on the most recent data from the Gaia telescope that essentially collected the data for so-called wide binaries. Various star systems containing two stars that are usually separated from each other by at least a few thousand astronomical units. And at these distances, this is where we should be able to observe MOND effects, which is precisely what this study was about. This was from November of 2023, and in a nutshell, it discovered an overwhelming evidence for regular Newtonian physics in orbits of these various binaries. So basically here, this was one of the first major failures for this MOND hypothesis. Here MOND predicted that a lot of these stars would orbit approximately 20% faster than expected. Yet thousands and thousands of stars were orbiting just as Newton predicted, with the actual sigma value being super high, suggesting that this is extremely unlikely to be by chance. But naturally, not all MOND scientists agreed with this. Obviously, for a lot of them, this is their whole life here, so there's going to be a lot of disagreements. There were some additional studies trying to disprove this by using similar data, and though they had some success, it was not as significant. Okay, which means that maybe we need more evidence. And well, that extra evidence was just released on March of 2024. Here they tested MOND for a lot of different bodies right here in the solar system. And that's because we shouldn't just be observing MOND effects for different galaxies. It should also have effects on various comets and various asteroids on the outskirts of the solar system, the places where the acceleration is very low. And this was actually one of the first solar system tests for MOND, mostly based on various trans-Neptunian regions at distances over 100 astronomical units away. And so here, by observing things like, for example, comets, the researchers confirmed that they seem to have a much more narrow distribution of energy compared to what's predicted in MOND, with a lot of the bodies orbiting in these various regions only containing slight inclination to the plane, compared to MOND, where this inclination is predicted to be much larger. By the way, MOND in this case was also sometimes used as a potential explanation for the mysterious Planet 9, and this study basically suggests that none of this would make sense. Here, the MOND once again kind of fails to recreate what we see, and the variety of planetary bodies or comets on the outskirts seem to once again obey Newton, not modified Newton. Not to mention that it makes absolutely no sense for galactic clusters, such as the famous Coma cluster. One of the recent studies tackles this as well, and unfortunately MOND cannot predict motions of galaxies within clusters, whereas Newton plus dark matter definitely can. As a matter of fact, surprisingly, for many clusters MOND does not provide enough gravitational effect. Whereas on the outskirts of most clusters, according to MOND there should be a lot more gravitational effects, but that's not what's observed in these studies. And so here galactic cluster sampling establishes that MOND once again unfortunately fails. And lastly, one of the recent studies also decided to focus on one of the predictions involving Saturn. This is actually the most recent study from May of 2024, and here it involves the prediction from MOND known as the solar system quadrupole, something that should be responsible for changing the orbits of planets just a little bit on a scale that should be observable if we have really accurate devices on those planets. And so for this particular study, turns out that we could actually use data from the Cassini mission. The mission that was orbiting Saturn for over a decade and that was able to collect extremely accurate orbital data between 2004 and 2017. And so here, because of MOND, the rest of the galaxy should have a very minor effect on the orbit of Saturn that would shift its orbit by just a little bit every once in a while, enough to be detectable by various accurate probes, but not enough to be detectable by telescopes from planet Earth. And so here, as Cassini was orbiting Saturn, it was actually sending out various radio pulses that were then received on planet Earth. And that allowed us to measure extremely accurate distances to Saturn, allowing for an extremely accurate calculation of its overall orbit in the solar system. And once again, just as in previous studies, by using the values from these radio pulses, it was discovered that there seems to be no MOND effect on Saturn either, and there were no unusual anomalies here, as expected in the MOND hypothesis. Or basically Saturn was orbiting as predicted by Newton without the need for anything else. Moreover, even when the scientists tried to tweak the calculations a little bit, just to see if it fits with any other similar models, the answer was no. It only seems to fit with Newtonian dynamics and with Newtonian physics. Once again, the results here were very significant. And that basically meant that there seems to be no reason to have this unusual quadrupole, which is usually quoted as one of the most important propositions of the MOND hypothesis. And so this other proposition, known as the EFE or the external field effect, seems to not exist either. And so by itself, these are really important studies that find a way to scientifically disprove something which is the basis for most scientific research. And by doing this, by disproving MOND, we now have to focus on possibly finding something else as an explanation. Because the effects of dark matter are still there. They're undeniable, they seem to be very powerful, but we just cannot explain it using modern theories. None of the proposed particles so far have been discovered, with only possibly 2 axions or some kind of an unusual neutrino still being viable candidates. But at this point, this is actually even more exciting because now, after a few decades, we know what it's not. It does not seem to be a quirk in gravitational formula, and it does not seem to be some kind of a massive particle, invisible particle, such as the famous WIMP, weakly interacting massive particles. But it's definitely something requiring research because there is so much of it everywhere, and it seems to be responsible for affecting pretty much everything in the universe. And so here I guess we go back to the original Fritz Zwicky's proposition. At this point, we don't really know what it is. It really is dark matter, the matter that's invisible and unknown. But despite these studies, we're not really closer to the actual answer of what it is. There is, however, a chance that maybe in the next few years, some of the most advanced and most recent dark matter detectors might finally discover something. Today, I wanted to once again discuss a somewhat bizarre phenomenon discovered just a couple of years ago. A phenomenon that involved the most energetic, transient astronomical event visible in optical light, or essentially an explosion that we can actually see with our own eyes, but in this case an explosion that lasted for at least 3 years, or ever since it was discovered. And the event so bizarre and so strange that it basically became known as Scary Barbie. But for reasons I should probably explain first. This was discovered by the famous ZTF or Zwicky Transient Facility, an automated telescope that's able to directly detect various changes in brightness somewhere out there in the night skies. And in this case, the word transient refers to the sudden change in brightness somewhere out there. And so basically here it's looking for things like supernova. But on April 13th of 2021, it once again detected something, but this time something very strange. Because this is an automated facility, it usually names things in a very specific but somewhat random way, and so this time, this event received the name that you see right here. And because in this case the letters resembled Barbie, and also because it was somewhat unusual and somewhat bizarre, over time it became known as Scary Barbie. And to date, it seemed to be one of the most powerful optical events ever discovered. Now, not the most powerful explosion, that record belongs to something else we discussed recently, the gamma ray burst that we've discussed right there, in the description below, but even in this case, the amount of energy emitted was really huge, especially because it's been doing this for practically 3 years now. But the reason it's actually known as Scary Barbie and not just Barbie is really because of the mystery of its origin. Nobody has any idea what's actually happening here or what created this. Because normally, when we see some kind of an event like this, we expect this to be some kind of a star or some kind of a massive object being shredded by the supermassive black hole. So basically a TDE, tidal disruption event. But if it's a supermassive black hole, we expect it to be in the middle of a galaxy. Yet despite various observations using some of the most powerful telescopes, pretty much nothing has been discovered in this region so far. There does not seem to be a host galaxy, thus making this a super intriguing and somewhat unusual discovery. A discovery of an explosion, a very powerful explosion, but that seems to be happening right in the middle of empty space. But moreover, unlike other TDEs or other disruption events, here it has not diminished in brightness almost at all, and ever since it started brightening years ago, it sort of remained the same. And so the question was, so okay, what's happening here? What can this possibly be? And is it aliens? It's not aliens. But yeah, the question is really, so what's up here? What is going on and what can possibly create such a powerful explosion? Well, right now, a quasar or any kind of an AGN or active galactic nucleus is pretty much out of the question. It would have been detected a long time ago. As a matter of fact, a lot of similar very powerful emissions have been detected before, such as the one you see right here in a galaxy MS0735.6. This is technically a galactic cluster, and it's also producing very bright and very stable optical emissions, but here there is a galaxy in the center and a lot of galaxies around it. And so in that sense, this is definitely maybe similar, but not the same. Moreover, the spectral line features that can usually tell us about the elemental composition and even the origins of these events seem to be extremely different from a typical TDE. And so basically it looks very different from your traditional supermassive black hole shredding a star. For example, here we don't actually see any neon, any oxygen, or specific types of nitrogen or helium, something that's expected from certain TDEs and certain active galactic nuclei. And moreover, in 14 months of observations, the spectra did not change at all, and that's also very strange for a typical TDE. Nevertheless, we still have some explanations and some potential new discoveries that you can learn more about in some of the recent studies in the description. For example, when it comes to the missing galaxy, because this is actually pretty far away from us, the redshift of 0.99, or approximately 8 billion light years away from us, it has been suggested that we're just not seeing the galaxy, because it's relatively small in size, and also because it's possibly hidden by a lot of dust, and would thus be below the detection limit for a lot of modern telescope surveys. So basically here, if the galaxy is enshrouded by a lot of dust, it would be somewhat difficult to detect, but could also maybe explain why we're observing so many optical emissions. If there's a powerful black hole in the middle, it would make a lot of gas around it extremely bright in certain frequencies. On top of this, in one of the most recent studies you can find in the description, researchers wanted to discover if more similar events were discovered somewhere else in some of the older data, with their initial search returning 59 events, but only 7 of them ended up being very similar to the Scary Barbie, and they now refer to them as ANTs, ambiguous nuclear transients. Or I guess, for the lack of better words, strange explosions that basically currently make no sense. And in total, 10 such ANTs have been discovered to date, representing very bright optical flares that can usually last for 2 or more years, in contrast to a typical tidal disruption event. A typical TD usually only lasts for 100 days. Likewise, in most of these cases, these ants resemble some kind of a very hot object, approximately 10,000 Kelvin in temperature, with very powerful X-ray emissions, essentially resembling some kind of a very hot, very bright star, except that they're not stars and seem to be visible from billions of light years away. But pretty much all of them, except for maybe one, seem to also display an extremely powerful infrared flare, suggesting something really hot around them. And here researchers believe that it's most likely from some kind of a dust echo, or basically a very large dust cloud around something that seems to illuminate this dust, which then starts to glow in infrared. And in that sense, it basically suggests that it's most likely some kind of a supermassive black hole once again. But possibly supermassive black holes that seem to be located in either bizarre galaxies or possibly in extremely small galaxies with practically no stars, with the actual explosion or the brightening event most likely being the result of a very powerful accretion disk around these black holes. But exactly what's causing the accretion don't currently agree. Some still believe that it's possibly just a very strange version of a tidal disruption event. For example, for that scary Barbie, they think it's maybe some kind of a very massive star, approximately 14 solar masses, being shredded by a supermassive black hole that's 170 million solar masses in mass. But because in this case this particular black hole seems to be very massive, yet it doesn't seem to contain any galaxy around it, a lot of this currently makes no sense. While other researchers think it's something else. They actually suggest a really huge gas cloud, possibly thousands of solar masses in mass, interacting with a massive black hole that produces these long-term emissions. Although in this case, the inferred mass of the black hole is also once again at least 100 million solar masses, possibly even more massive. And that's just based on the brightness visible from 8 billion light years away. And so once again, even this explanation does not really make a lot of sense. If this is a massive black hole, how come we're actually not seeing anything around it? And why does this massive black hole appear so different from any other black hole discovered so far? And so in that sense, there are still obviously a lot of unexplained questions. But I guess the most important discovery coming out of these recent papers is just the fact that the scientists found more. More of these very unusual, unexplained, transient phenomena that appear as very bright flashes that don't seem to change much for years and seem to be very bright in optical emissions, or basically easily visible with a relatively powerful telescope. As a matter of fact, one of these events is already known to have lasted at least twice as long as Scary Barbie. The event known as ZTF-19 AAMRJAR. I guess armjar or something. But basically overall, this is still a bit of a mystery. A mystery of these unusual, very bright optical events that, though similar to a typical TDE, seem to be very unique and very peculiar. As a matter of fact, they are so peculiar that there's just not much else to say about them because we don't really know what's going on here. And if you watch that older video from just over a year ago that you can find in the description that describes the discovery of this event, unfortunately I've not actually added much more information here because we haven't learned much about these events since then. And so in that sense, this is just going to remain a mystery, like so many other transient events that even now have no explanation. But of the ones that really make no sense, this one is definitely somewhere on top. I mean, just the fact that even now nobody has actually found any kind of a galaxy here is definitely very surprising. And so if there is some kind of a black hole here, and it's like really massive, it seems to be basically a rogue black hole, just traveling by itself and suddenly interacting with something, maybe a star, maybe a massive gas cloud, which suddenly made this black hole extremely easily visible from very far away. But if this is a rogue black hole with hundreds of millions of solar masses in mass, the question is, where did it come from? And so I guess we're just going to leave it at that. It still remains a mystery, there are still not a lot of questions that have been answered, but we now know of 10 such events. And so whether this is a tidal disruption event of some kind of a massive star, or possibly a disruption of some kind of a massive cloud, we're not going to know until future discoveries and future observations. Hello info person, this is Anton, and let's discuss the famous wow signal once again. But first, just a little bit of a background so that we're all on the same page. And it all started sometimes after the Second World War, when the radio astronomy really started to pick up. Back then, a lot of astronomers started to propose that, hypothetically, if there was some kind of an alien civilization out there, and it really wanted to announce its presence, or possibly communicate with someone else, it would very likely rely on the so-called hydrogen line, the frequency of 1.421 MHz, created by the transition of neutral hydrogen when it changes its energy state, in the process releasing an extremely specific frequency of light. The light with wavelength of 21 centimeters, and the light that can technically penetrate everything in the universe, easily moving through all of the dust in the universe without being blocked by anything, and in some sense, visible from everywhere all at once. And though naturally this is also created by pretty much most of the hydrogen clouds out there, if someone were to make these particular emissions appear artificial, or basically modulate them in such a way that they definitely appeared as they were produced by intelligence, in some sense all of this would produce a perfect way to not just announce your presence to everyone out there, but obviously also communicate over long distances. And so back in 1959, an Italian physicist, Giuseppe Cocconi, who you see in this image from 1967, along with the American Philip Morrison, proposed searching for extraterrestrial intelligence using this 21 centimeter hydrogen line. And essentially based on the assumption that any kind of an extraterrestrial intelligence might be basically doing the same, mapping the universe using the hydrogen line, and would thus maybe decide to announce itself using this very specific frequency. And so based on these early principles and these early assumptions, radio astronomers started to basically look around the night skies trying to find something. And approximately 2 decades later, while working on the Ohio State University Big Ear Radio Telescope, Jerry Eman, who you see right here, detected an unusual signal in that frequency that lasted for 72 seconds and was coming from the constellation of Sagittarius. And because this was such a surprising discovery, the astronomer marked it as WOW, which eventually led to this being known as the WOW signal that remained a mystery for several decades. And because of its unusual properties, this was assumed to be maybe coming from extraterrestrial intelligence somewhere out there, with the value itself being extremely close to the value of the hydrogen line, but much stronger than anyone expected. And as a result, several follow-ups tried to rediscover the source of the signal or possibly hear it again, with SETI also conducting several follow-ups, including potential technosignature search, trying to see if they could hear something else. But years and years after, still nothing. No technosignatures, no additional signals coming from this location, and more importantly, even Jerry Eman, who discovered this, mentioned that we should have heard it again if this was coming from an alien species. And so he even proposed that maybe this was actually coming from Earth and was just basically a reflection from some kind of a satellite out there. But that was extremely unlikely, just because of the chances of that happening, and because back then there were just not a lot of satellites to reflect from. And so naturally, so many different explanations have been proposed over the years, with pretty much all of them suggesting that this was a natural phenomenon. But here, before we tackle the best one, let me actually tell you a little bit more about the signal, just so that you understand what we're looking at. So first, the letters and the numbers. This is not an actual message, and instead represent a signal strength denoted by numbers and then letters, with U in this case representing the highest possible signal-to-noise ratio. And so in that sense, this just tells us that this was an extremely strong signal. But more importantly, if graphed, it looks like this. You have a signal becoming stronger and stronger for approximately 36 seconds, which then peaks and starts to diminish for the next 36 seconds. And that signal had no modulation and no additional information in it. It basically resembled a kind of a extremely strong beam in that frequency of 1.4 GHz. But timing here is also extremely important, because this actually shows us something else. Because it was exactly 72 seconds, this actually showed us that this was the result of the Earth's rotation, or basically that it was extraterrestrial and was at first coming into view for 36 seconds, then peaked, and then started to move away from us for the next 36 seconds, with the source itself very likely being extremely far from the planet. But because there was no modulation, and this appeared to be some kind of a continuous wave, the main reason the signal was so exciting is really because we've just never seen anything like this before. It was the first such signal ever found, but in reality it really had all of the signs of some kind of a natural phenomenon. A phenomenon coming from that constellation of Sagittarius, and possibly caused by something involving hydrogen. Nevertheless, for many decades, a lot of scientists tried to see if we can actually maybe find the source of this, or possibly find technosignatures coming from this location. In the last 5 years, there were a few papers that first estimated where this possibly came from, and then even tried to find individual stars that might contain some kind of a planet where the signal could have originated. Obviously in this case, assuming that this was from some kind of a civilization. But because the signal has never been detected again, and because once again it just appeared a little bit too natural and not artificial enough, most scientists did not think this was aliens and actually proposed quite a lot of additional explanations. For example, apparently, according to Antonio Paris, one of the astronomers in Florida, around this time there were a couple of comets in the same regions of the night skies. And he actually proposed that maybe the hydrogen cloud surrounding these comets could have produced some kind of an effect. But most astronomers actually don't think it's possible, and so this particular hypothesis, despite being interesting, was rejected pretty quickly. And then we have this new proposition, the proposition from August of 2024, that right now doesn't just make sense, it makes a lot of sense, and might even lead us to some other discoveries involving other mysteries, such as FRBs or fast radio bursts. And so let's talk about this recent paper that was just released that potentially solves the wow signal once and for all. Now the lead author here is Abel Mendez, who is pretty known on his work in Arecibo Observatory, but also for developing the famous Earth Similarity Index that's usually used in describing various planets and comparing them to planet Earth. And so for the past 7 or so years, Mendez and his team were working on analyzing radio data coming from various regions containing famous red dwarf stars with potentially habitable planets. And so here they were looking at planets in systems like TRAPPIST-1, trying to discover any potential radio frequencies between 1 and 10 GHz. And this was based on some of the older observations from Arecibo, but also from other observatories as well, and they had quite a lot of data collected. But while observing these stars and obviously looking for signals coming from their planets, they started to discover something entirely different. They started to discover a bunch of bizarre signals around various celestial objects that surprisingly resembled the wow signal way too much. And here this wasn't just one or two, it was a lot all over the place, with a lot of recent observations basically resembling wow signal, just not as powerful, but in an extremely similar narrow band and with a very similar profile. And though naturally the first assumption here is that, okay, I guess there are aliens everywhere trying to communicate, the more realistic explanation is that these are actually natural phenomena formed by something very specific. Here by focusing on the T-Garden star, mostly because it contained the longest drift scan so far, they observed various signals consistent with something produced by cold hydrogen clouds. But here these clouds were suddenly brightened by an extremely powerful transient, or by possibly some kind of a stellar emission that very likely lasted for just a brief moment, but was powerful enough to suddenly make these clouds extremely bright, emitting a lot of radio light in the process. Specifically emitting what we usually refer to as a maser, or I guess for the lack of better words, a microwave laser. A well-known astrophysical phenomenon that's usually present around various clouds. Here's one of the more famous examples in the Jellyfish Nebula. And so these natural phenomena usually occur in various microwave or radio frequencies when something very powerful excites a molecular cloud, making it emit tremendous energies. Which means that something extremely powerful must have happened in the vicinity, causing these hydrogen clouds to start emitting these masers visible all the way from planet Earth. And though we obviously have no idea what exactly was this transient and what caused these clouds to appear this way, the researchers in the study believed that it was possibly some kind of a magnetar or a similar powerful object able to create very powerful emissions very suddenly. And so in essence, this schematic right here kind of explains what they think might have happened. Some kind of a powerful source hit the hydrogen cloud, which was then visible from planet Earth. And based on the observations of hydrogen clouds in the vicinity of these signals, this does seem to be like the more likely explanation right now. But no observations of the actual source of the transient, so basically we don't actually know if this was a magnetar or something entirely different. But intriguingly, if they're correct, and right now the evidence is pretty strong, it essentially then suggests that the wow signal was just a very unusual example of some kind of a rare astronomical event involving a hydrogen line maser flare, and possibly even the first one ever seen, but in this case also extremely powerful, and possibly caused by some kind of a very powerful transient. And so now the obvious question becomes, so what? if this was a magnetar, and if it was able to create these powerful radio emissions by shining at this hydrogen cloud, this could provide important answers for another mystery, the famous FRBs or fast radio bursts that to date still don't have a good explanation, but have always believed to be caused by magnetars, possibly involving some kind of a cloud or some kind of a pulsar nebula. And because similar clouds do actually appear in the vicinity of the famous magnetar that produced FRBs right here in the Milky Way, all of this could potentially have extremely similar origins. But that's assuming that it was caused by a magnetar. Right now, as far as I know, no magnetars have been discovered anywhere in the vicinity, and so we don't really know what caused these clouds to become so bright. But since astrophysical masers are usually exceptionally rare, to astrophysicists this is going to be a super exciting discovery. To date, one of the first discovered and possibly one of the best known masers out there is the one coming from the star MWC 349. And in this case, it seems to be caused by some kind of a nebula around the star, or possibly even coming from the star's disk. And so by discovering so many masers out there, with all of them basically resembling the famous wow signal, in essence kind of resolves one mystery, the mystery of the wow signal itself, but creates a new mystery, the mystery of their origin and what's causing so much energy to be released to suddenly make these clouds so bright. Naturally not something we're going to be answering yet, but I'm sure in the next few years, with additional observations and additional studies, we'll possibly have new answers and new resolutions. Hello wonderful person, this is Anton, and today we're going to discuss something a little bit more unusual about our own planet. An unexpected discovery that once upon a time, and specifically approximately 500 million years ago, Earth extremely likely had a set of rings. Rings not so different from the ones around Saturn, and rings that eventually had an extremely similar fate. They basically disappeared, falling onto the planet. And so let's discuss this somewhat unusual new proposition and all of the evidence behind this, while also connecting this to several events that happened on our own planet around the same time. And I guess let's start with the period itself. If it happened, when was this, and what was Earth like back then? Well, based on a lot of geological studies, we think Earth potentially resembled something like this. This was during the so-called Middle Ordovician period. Here's actually maybe a slightly better picture that shows us some of the continents. And during this period, most of the complex life resided in the oceans. Some of the strangest life resembled these very bizarre cephalopods known as endoceras that were basically kind of like squid wearing extremely long hats. But we also know that around this time, most of this life suddenly disappeared. This was one of the more well-known mass extinction events, referred to as Ordovician Silurian extinction, that eventually led to an extremely important event referred to as Great Ordovician Biodiversification. As the name implies, this was when a lot of life suddenly started to diversify, producing an enormous amount of species that then started to colonize land. And though we know about all of this from a lot of different sediments and a lot of geological observations, the actual triggers or the actual causes of this were not entirely clear. But there's always been that one particular explanation that actually involved multiple meteorite collisions. This is sometimes referred to as Ordovician meteor event, and it's an unusual period approximately 467 million years ago, where for some reason there's an unusual abundance of various impact events on planet Earth. And previously this was suggested to be a result of some kind of a large asteroid, possibly 150 kilometers in size, breaking apart in the asteroid belt, maybe because of a collision, with pieces eventually making it to planet Earth for the next 20 million years. Here's actually where some of these craters have been discovered, with all of them occurring in a relatively similar time frame. And so the assumption from these previous studies from approximately 4 to 5 years ago was that, well, maybe these asteroid collisions eventually resulted in climatic changes, resulted in the extinction event, but also forced a lot of life to diversify in order to adapt to these new conditions. But up until this point, or up until this paper, nobody actually made the connection between these asteroids, and all of this was somewhat speculative. But this new paper did something different. The study by Andrew Tompkins, Erin Martin, and Peter Cowwood was able to find an extremely unexpected connection. And actually it's a connection between these previous impacts and a few more on other continents. Or in other words, if we were to essentially convert this image to how Earth looked 470 million years ago, we suddenly start seeing an unusual pattern. There's a very significant impact clustering. All of these craters seem to have happened along the equator and not in the higher or lower latitudes. And so here we had an extremely close spacing in time, in space, and also along the equatorial line. This was based on 21 craters from around the same time, and all of them were within 30-degree latitude of the equatorial line, with additional evidence from sediments also suggesting elevated levels of meteorite debris, confirming multiple collisions. And though at first it was obviously not apparent what could have happened here, eventually the researchers realized that it very likely represented an ancient ring that was slowly falling onto the planet. And that's because it's difficult to explain why all of these meteorites would fall in the same region along the equator and not anywhere else. And so since this only affected an extremely small part of the planet, it would be very difficult to explain in any other way. But naturally this is still very speculative, although definitely not impossible. And not impossible because we know that at least 4 other planets in the solar system currently contain rings, very likely produced in a very similar way. Here this would involve a relatively large asteroid getting stuck in the orbit around the planet, eventually being tidally disrupted and shredded apart, forming a large set of rings. But just like with Saturn, we know that these rings are not forever and eventually crash into the planet. As a matter of fact, except for the 4 giant planets, it's believed that Mars also had rings at some point as well, and may even have them again when one of its moons gets shredded apart once again. And though previously scientists believed that maybe Earth also had rings during the early period when the moon was being formed after the Theia collision, as you might have learned from one of the recent videos, at this point we don't even know if the collision with Theia actually happened. But based on this recent research, rings may have existed in the last 500 million years. But the signs of these rings would have already disappeared a long time ago. Mostly because these rings are expected to exist for about 40 million years, which does represent a somewhat similar time frame to various asteroid collisions detected around this period. And so this unusual Ordovician spike resulting in multiple impacts could have been because of a broken asteroid in the asteroid belt, but it's now looking more likely that all of this was a result of an asteroid being trapped around Earth, eventually forming rings that then fell onto the planet, with the rings surviving for 30 to 40 million years and leaving their mark on the planet still visible in the geological record. Now, because the Roche limit for planet Earth, or basically that limit where a typical asteroid turns into rings, is approximately 15,800 kilometers or 9,800 miles above the surface, it means that the rings themselves would have been easily visible from planet Earth, and more importantly, would have actually cast a shadow. You can kind of see that shadow being cast right there by the rings of Saturn on the Saturn itself. And as you can imagine, that shadow meant that the Earth was not actually getting as much solar illumination. And this could have potentially cooled down the planet. And so in this study, the researchers make another proposition. They actually suggest that the shadow from these rings possibly resulted in one of the glaciation periods that lasted from 460 to 420 million years ago, dramatically cooling the planet and forming enormous ice sheets, even bigger than the ones in the last 3 million years. And because this ring that lasted for about 40 million years seems to correspond to the glaciation period, right now, though speculative, the evidence is still kind of intriguing. But in order to see if this makes sense, more evidence needs to be discovered, and more importantly, we need to have modeling. Basically modeling explaining how the asteroid would break up, what exact effects it would have in the orbit around planet Earth, and how this would affect the climate of the planet. And so assuming that the study in this case is correct, this unusual event possibly had an extremely dramatic effect on the planet and of course the evolution of life. But because this is such a big proposition, and because there are obviously other explanations, this is still extremely preliminary. And so whether Earth actually had rings, which potentially caused all of these effects, including a glaciation period, or if all of this was a result of some kind of an asteroid breaking apart with pieces eventually crashing on the planet, we're not going to know until future studies. But if one day it does turn out that this is maybe correct, it means that by producing these unusual rings around the planet, through, for example, some kind of an asteroid redirection, we can actually find a somewhat intriguing way to change climate of planets. For example, scientists behind the study propose maybe one day using this on Venus. So basically by forming Venusian rings, we can dramatically cool down the surface of the planet, possibly triggering an event that can help cool down the planet even more, which would then lead to a dramatic reduction in the atmospheric pressure and basically initiate a kind of a terraforming event. But in some sense this is all still purely speculative and does require a lot of confirmation. And so until future studies, check out all of the links in the description below. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.